Okay, is this on? It is on. Cool. All right, just going to wait another 30 seconds or so for a few more people to roll in. Okay. Right, well, I'm sure people will keep on walking in, but we'll just let people do that. That's absolutely fine. So let me get started. Right then, good morning. Welcome. Thank you very much for making it over here. I understand that you might have had a late night with the attendee party last night, and hopefully that has resulted in you having lots of energy this morning, full of excitement for all the cool demos and things that we're going to see in this talk today. I think that's how it works. So my name's Steve, and I am a developer at Microsoft. I work on the .NET team, and I particularly focus on web-related stuff. And that is what we are going to be focusing on today, the web. So the web is an enormous part of the software industry. It's the biggest deployed software platform in the world. I would strongly expect that more developers are focused on the web than anything else. Even though there's lots of hype in other areas, the web is still a dominant focus for developers. So hands up if you do something related to the web in some way today. So yeah, obviously it's just about everyone. It's certainly the great majority of people. And since so many people are working in this area, there's loads of change happening all the time, loads of innovation, always new ways to do things. And that's cool. It keeps us in jobs, and it gives us new and improved ways to do things. And that's kind of what we're going to talk about today. What's changing at the moment, what the big trends and patterns are, how web development is likely to look over the next few years. Okay, so in this talk, just to set your expectations, there's kind of two main parts to it. We're going to spend the first half or so, maybe 2/3, looking at what you might call web applications, things that usually result in some kind of user interface in a browser. And we'll look at lots of different web frameworks and look at what they're doing and how they're changing over time. And then for the last part of the talk, we're going to think about the server a little bit more, some stuff that's happening on the back end in the cloud, and the way that other web technologies, specifically WebAssembly, could change the way that that is done. I'm sure most of you have heard of WebAssembly. Many of you may have heard of WASI as well. But I don't know whether you've heard that WASI is going into its version 2 or preview 2 at the moment, which is very different from preview 1. So we're going to be looking at what the big new ideas in preview 2 are and how it's going to solve some of the big problems from preview 1. Okay? So let's get started with web applications and web UI. And to understand this, I find it helpful to have a bit of a timeline, so we can see how things have been changing. So we could start right back from when the web was first invented, right at the start of the 90s. And how did we do web UI back then? Well, there was only one way to do it. It was to render HTML from your server. And so you would have some Perl or Python or not really Python back then, it would be Perl or PHP, maybe ASP.NET, and they'd be running on your server, probably in a CGI bin directory, and they would be emitting HTML. It was all we knew. We didn't have JavaScript. We didn't know any other way to do things. Well, JavaScript wasn't even invented until most of the way through this, and even after it was invented, it was kind of nightmarish at that time. I mean, it's great now, but back then it was like an abomination. So people weren't really using it, and they were just producing HTML on the server. Of course, people still do this today. There's nothing wrong with that. And in fact, you might be doing more of this in the near future as well. But by about 2005, people started to outgrow this a little bit. There was this whole movement called Web 2.0, where people were trying to make richer user interfaces. And to do that, they had to start using JavaScript, even though it was still not very good back then. And so libraries came along like jQuery, which is still big today, and that made it more practical to build some bits of interactivity from your server-rendered HTML pages. But again, people started to outgrow this. So by about 2010, people wanted things that were a bigger application, and their jQuery code was getting too messy. They needed more structure, and so we started to enter the early phase of client rendering. So this is where libraries brought patterns like MVC or MVVM into the browser with JavaScript, and we had names like AngularJS and Knockout, Backbone, Ember, that kind of thing. And for about 5 years, that's how people were doing their cutting-edge web UI. But again, people started to outgrow it because their apps got even bigger, and these early client frameworks, they just weren't structured well enough to write a really big application. And the thing that really changed stuff is when React came along in about 2015. I think that changed the rules of the game a little bit, and that brought us into the modern era of client-side rendering with full spars, and various other frameworks came along after that to use some of the same ideas. Okay, so that's kind of where we are up until now. But again, we're starting to outgrow this. And this time, it's kind of to do with the performance and compatibility, because we're writing so much code that goes into the browser now that it's starting to be a drag, especially on lower-end devices. And some of these client-side frameworks are starting to say, hey, there's this whole untapped resource here, the server. Couldn't we run our client-side logic on the server? You know? And so we're seeing the movement of frameworks like React is now running on the server inside Next, or Vue is running on the server inside Nuxt, and various other frameworks that are combining the power of the server and the client in new ways. And that's what we're going to spend quite a bit of time looking at this morning, and how different frameworks are approaching that. So the biggest idea in this space, and there's various ideas, but the biggest one that we're going to start with is the idea of server-side rendering as the first class thing. The first thing that you're doing, server-side rendering, for as much of your site as possible, and then just having bits of interactivity in little islands where it's required. And we'll talk about the pros and cons of that in a minute, but let me just start with a demo, because we all love seeing some demos. Okay, so just in case you didn't realize, this is a technical keynote, so there's not going to be that much slides. There's going to be mostly demos and code. I hope you'll manage to follow along. Some bits might be a bit advanced, but even if they are, don't worry, because I'll move quickly and we'll keep moving on to new things, and you can just pick up whenever we get to the next bit. All right, so let's have a look at Next and how it uses React on the server. Okay, so let me just start up this application that I've got. I'm going to move into my Next dashboard and do an npm run dev to get that started. Okay, so the site that I'm trying to build here is some sort of management portal for people who run software development teams. Okay, so if you're a software engineering manager, you'd want to know about your staff and your projects and stuff like that. And then I've got this dashboard page over here, and inside there, we can see the status of the current builds, we can see the issues that have been filed, and then my favorite bit is we can keep track of all the employees, exactly how many lines of code they've written today, if they've been wasting any time, and then we've got cameras pointing at them to detect their mood and figure out how we should manage them. So I call this surveillance-driven development. I think it's probably the future of engineering management. I can't think of any drawbacks to it anyway. So we'll get back to this in a minute, all right? But first, let's just see how this site is working and what we can do to improve it a little bit more. Okay, so like I said, this is a server-rendered site, but it is built with React components. So if we look over here in our code, if we go into our app and then our homepage here, this is the code where we've got this to-do message, and you can see the same thing in the browser over here, okay? Now, even though this is a React component, as you can see, it's just producing server-rendered HTML, and there's no JavaScript for this going down to the browser. So if we want to see in our HTML sources, if we search for to-do, : you can see, it's very difficult to read, but there we go. There's the actual HTML that's been emitted from that specific component right there. Okay, so we can do server rendering, and that's what happens by default. So no scripts for components are going to the browser by default. But we can use other components as well. Let's say I've got this other component here called clock, which is going to display the current time. So if I add that into my page, then it's going to show the current time very, very precisely, as you can see, very useful. Okay, and how does that work? Well, it's just a standard React component. So it works with server rendering by default. Here's the markup that that's going to emit. But it's also aware of whether it's running server-side or client-side. By default, it just runs server-side. But if we want to, we can turn this into a client component. And then the framework will send the code for it down to the client, and it will run on the client. And as you can see, if we're on the client, we've got this set interval, so we're going to update the time as we go. So to do that, I'm just going to add this magic marker at the top, use client. And then when I go back to the browser, you'll see it now has sent the code for that component down to the browser. So even though the rest of the site is server rendered, that one little island of it is rendered on the client interactively. Okay, so that's kind of the central idea in this sort of approach to web UI architecture. And the reasons why you might do that, well, there's quite a few actually. The most obvious one is that you're just sending less code down to the browser. We didn't have to send any code for the rest of our components other than the clock just there. So that reduces the load. This can reduce your costs as well. Firstly, it reduces obviously your bandwidth costs. But if you're using some framework like Blazor, which either works with WebAssembly or a WebSocket connection, it can be advantageous not to have to use either of those. If you don't need WebSockets or WebAssembly, then just don't, just have HTML. That can reduce your hosting costs. It also means that you can have better compatibility. So if you're trying to have users with low-end mobile devices, maybe it's quite slow for them to download and execute large bundles of JavaScript. So just plain HTML is going to work better for them. This one's a little bit funny. I don't know if you'll agree with this, but it means that as a web developer, you will spend more of your time thinking about traditional HTML concepts rather than concepts that are specific to a UI framework. So you won't think so much about React or Vue or whatever. You'll think more about HTML and how the web sort of intrinsically works. So that gives you slightly more like timeless and transferable skills, whether or not you like that. And then finally, of course, it doesn't stop you from having as much interactivity as you want. And we've had this term progressive enhancement for many years, and now it's applying in this new way with these frameworks that can progressively enhance server-rendered HTML with client-side execution. Okay? So we've just looked at Next.js, which is built with React, but there are many other frameworks that are starting to do the same thing. Most of them are tied to specific UI frameworks, like Nuxt is the server framework for Vue, SvelteKit is the server framework for Vue, Blazor is the server framework for Blazor. It's a bit confusing, but it is, and so on. We'll look at some of these others as we go. And what I think is an interesting thing to observe is that they're all kind of agreeing with each other about what sort of features are needed for this architecture to be effective. So let's have a look at each of these 4 features and how they show up in different frameworks and what they accomplish. But also, I don't want you to think of these features as just magic. I want you to understand how they actually work inside. So for some of them, I'll show you how you could implement it yourself with a bit of JavaScript without even needing to have any kind of third-party framework. All right. So we've already looked at server-side rendering, and that's kind of easy to understand. We take stuff that would normally run on the client, but we run it on the server. Now, there's also a slightly more advanced version of that called streaming server-side rendering. And the point of this is to overcome one of the limitations of traditional server-side rendering, and that's to do with the first load performance. So let me show you that. I'm going to continue showing you that in Next for now, before we switch to another framework. So let's go back to our dashboard, okay? So I'm going to click on this link, and I'm waiting, just waiting for it to load right now. Still waiting. Ah, there we go. It finally shows up. Good. Now, if I click on reload again, I reload, and I'm waiting, and I'm still waiting, still waiting. OK, there we go. So why does that take so long to load? Let's have a look at the code inside there. All right, so this is the code for the team activity page. And you can see the place where it gets its data from is by making this call to a back-end service. And that takes a little bit of time because it has to check in with all the cameras and the AI systems and things like that. So we have to wait while this is happening. And that's one drawback with traditional server rendering is that you have to do all of your API or database calls before you can render the HTML. But with streaming rendering, we can overcome that. So let me show you how this is approached in Next, firstly. Okay, so here is our page for the dashboard, and you can see we've got the team activity in there. And inside React, there is this component called suspense, okay? And suspense means don't wait for this thing to finish loading. Just display this fallback content while it's loading, and then afterwards, swap in this content when it's ready. All right, now let's see what effect that has. So now, if I hit the reload button, We wait a moment for other stuff to load, but then instead of waiting for team activity, did you see we just saw a little spinner instead while that came up? So that's a slightly faster page load, or it feels it, because you see the rest of the page first. And we don't have to just have one of these. We could put suspense around all the slow parts of our site. Okay, so let's put one there, and we'll put one around here as well. And then let's go back, zoom out a little bit. Reload. Now you see we get 3 independent spinners, and these 3 different parts of the site can load independently, and the user doesn't have to wait for the slowest parts. They can just start interacting with the site straight away. So that's pretty cool. That improves the experience of server-side rendering. And it's not specific to Next. Actually, most of these frameworks have got an approach like that. I'm going to show you how this is done in Blazor now. Now, if you don't know Blazor, Blazor is a web UI framework for .NET. I know there's a lot of .NET people here, so I think most of you probably will have heard of it. But even if you haven't, or if you don't like it for some reason, whatever, it doesn't matter. Just think of it as an illustration of various concepts here. I'm going to show it quite a bit because it just so happens that I work on Blazor, so this is very convenient for me. So we need a scenario for our Blazor application. Let's think of some kind of web application that we might want to build. I've actually got an absolutely amazing idea, which I love. It's brilliant, and I can't believe that no one has thought of this before. It is my idea, so don't steal it, okay? So what this is about is the following. Okay, so has anyone ever heard of this, okay? This is a TV show called Twin Peaks from the 1990s. People heard of it? No? Okay, a few people have heard of it. All right, so cult classic TV show from the 90s. It doesn't matter if you've never heard of it, all right? It's just a TV show. And in this show, people drink quite a lot of coffee, okay? Anyone ever heard of coffee? Okay, yeah? All right, well, it doesn't matter, even if you've never heard of it, all right? It's just a drink, and it shows up a lot in this TV show. And having these two things together is, of course, incredible and brilliant. And I think I can make a lot of money by making a web application that allows people to keep track of when people drink coffee in Twin Peaks, right? Obvious business success there. So let me show you what I've started building already. Here's my site, Coffees of Twin Peaks, okay? And this allows us to keep track of when people had coffee right from the very first episode with that heartwarming moment where Laura Palmer got killed, right down to the very final heartwarming moment where Cooper gets attacked while drinking coffee, okay? And all the other coffee moments that we know and love from the years. It's making me tear up a little bit. Okay. All right, so we can also do things like we can search for particular series in there. Let's say we just want to know about series 3, or maybe we want to know about all the times where someone has been eating a donut while drinking coffee, and we can see that it's all the law enforcement agents. So, you know, some good cliches in there. Excellent. All right, so we're going to build some good features into our Coffees of Twin Peaks app, starting with streaming rendering. So you may have noticed that when I first arrived here, it took a moment to load. So we just wait about 1 second or so, or whatever fake delay I've put in for it to make sense, okay? And when I click on this button here, again, let's just change this. I'll click on clear, and we wait, and then it shows up. All right, so we're waiting a moment for some database call to complete. And we could make this feel a bit faster to the user by enabling streaming rendering. So let's do that. Okay, so I'm switching over to a different VS Code window. I'm using this nice Solution Explorer that's just become available in the last week or two. Pretty cool way of working with .NET and VS Code. And I'm going to go into my search page here. Okay, and this is where at the top we've got this form with the search controls. Below that, we're trying to show the results if we've got some. And down here, this is where we do a call to the database. Now, in Blazor, there is no suspense component. It doesn't need one because .NET has already got a pretty robust and well-understood system of using tasks to represent asynchrony. So if we want to enable streaming rendering on this component, all we do is we just add an attribute of stream rendering, okay? And then, hopefully, we should see some slightly nicer behavior. So when I'm back here and I click reload, you'll see I see the loading state while we're loading, or if I click on the search, we see loading. And the way that works is very simple. It's simply that when the page starts, it's going to do this call to the database, and it's asynchronous, so the results will initially be null. And then in the rendering logic, if the results are currently null, we'll say loading. Otherwise, we'll display the results below. Okay, so pretty straightforward, and that's how you would have built your component anyway, even before we started switching to streaming rendering. So In .NET 8, Blazor is doing server rendering by default. So inside my UI here, I am not using WebSockets, I am not using WebAssembly. This is just plain HTML going from my server into the browser. And so I don't have interactive features, but I do have the ability to do things like streaming rendering. Okay, now how does this actually work on the inside? So far I've made it just look like magic. Let's see how it's not magic and how you could in fact implement your own streaming rendering without even using any framework features. So to do that, I'm going to do it in C#. I'm going to switch over to my main program CS file, and I'm going to start writing a very sort of basic retro version of streaming, and then we'll make it a bit better as we go. All right, so I've got an endpoint on my server now, which is going to start by, it's going to do a loop, and then on each iteration, it's going to write hello to the response, and then it'll wait a little bit, and then it will do the same thing again. So if I go to this endpoint in my browser now, then we'll see that it says hello, 0, 1, 2, 3, and so on. Right, there's no magic or special thing going on here. That's just a slow HTTP response. And we can see it even more clearly if we do the same thing in curl. So if I go to my command prompt and make a request to that, you can see no magic, it's just a slow HTTP response. And that's how we could add content to the page incrementally without needing to switch over to client-side rendering. But how can we update content that's already there? Well, not too hard, actually. Let's just add a little bit of extra code in here. So I'm going to do not that. And firstly, I'm going to set the response content type, so the browser really knows this is HTML. I'm going to produce a bit of markup that says, hello, the time is, and then I'm just going to display a loading state in there. All right, so right now it says the time is loading, and it just does all this other stuff, okay? Now, what time do I want to put into here, or what content do I want to add to the page? Well, I'm going to add a little bit of content on each loop of this iteration. Okay, so on each loop, I'm going to emit a block of template content, which contains the markup that I want, the time, that is, inside a bold tag. And then I'm going to say where I want it to go in the UI. So I'm going to use this custom element called add streaming block, and I'll say I want this content to go into the thing with the CSS selector hash time. So that's this thing with the ID time. Now, template does not get rendered in the browser by default. So if I reload over here, you won't see that anything has changed. But if I did this in curl, you will see that this markup is in fact going to the browser. So all I have to do now is add a little bit of standard frameworky script that makes that element cause this content to go into the DOM. Okay, so I can do that with a bit of script like follows. Okay, so I'm defining a meaning for the add streaming block element here. And I'm saying that when this element gets connected to the page, we'll find the content that's in the previous template element, we'll figure out where we want it to go in the page based on that attribute, and then we'll use this very basic technique for just updating the content in that part of the page. A real implementation would be a bit more sophisticated, but this gives you the core idea. So now, if I go back over here and reload, then you'll see while it's loading that this clock is updating. And we didn't have to switch over to full client-side rendering. It's still server rendering, and the only script is just some standard thing that could be part of a framework. So that's really all there is to it. It's not magic, and that is how we're able to do things like this, where different parts of the page get updated with content while it's loading. Okay? So hopefully that gives you some intuition for how this could actually work. All right? So that is streaming rendering. Right, now let's move on and talk a bit about another feature. So enhanced navigation. This is designed to overcome another one of the limitations of traditional server rendering. So with traditional server rendering, each time the user clicks on a link, the browser throws away the entire page completely, loses all its state, and then fetches the new page entirely from scratch, including any content, any static resources that it references, except if they're cached. So you're losing all your state, and you get this kind of jarring experience each time you go from one page to another. Client rendering is a bit more efficient because it doesn't have to fetch everything again each time you navigate. So could we get the benefits of client rendering even when we're doing server rendering? Okay, so I'm going to show you this now from the perspective of another framework called SvelteKit, because I think that's the one that uses this term enhanced nav first, and they perhaps do quite a lot with it. So SvelteKit is a server-side framework for working with Svelte, which is another client rendering technology. And I'm going to start up a Svelte application just now. Ignore that warning, it's irrelevant. All right, now this Svelte application is basically just the default project templates for Svelte. Okay, it's got this kind of counter example, it's got an about page, it's got a Wordle clone for some reason, and then it's got a to-do page. Everyone needs to have a to-do example in their demos, right? Let's focus on how this page actually loads. So let's have a look at the browser network tab. And when I reload, if you look in the bottom left corner there, if you can see, we've done 64 requests to load this page. It's not optimized because this is just a dev build, but you get the point that it's loaded a load of static content in order to make this page work. And every time I reload, it's going to do those 64 requests again. But what does it do when I submit this form? So let's type in hey NDC, and I'll press enter on there. Okay, well, if you see in the bottom left, it's done another 63 requests. Well, it's cached one thing, but everything else has been reloaded. Again, why did it do that? Well, because this is just a plain traditional server-rendered HTML form. So every time you post it, it's going to throw everything away and start again from scratch. Now, we can do a little bit better with enhanced navigation. So let's go and see the code for that and how we could make it a little bit more efficient. So over here in my Svelte code, inside the to-do page, here we go. Right, here's the HTML form that you just saw. Okay, and in Svelte, there's a bit of syntax that we can add called use enhance. And that tells Svelte to upgrade this server-rendered form with some progressive enhancement so that it can evaluate itself client-side without reloading the page, even though you don't have to change the rest of your code. Right, so let's have a look at what happens now. So again, I'm going to reload, and I've done 64 requests. Let's clear that out. And now I'm going to type in another thing, and I'll press enter. And we'll see this time it didn't do 60-something requests. It just did 2 requests. And those requests, in fact, are now fetch requests. So some standard code that Svelte provides is evaluating that form submission using JavaScript and fetch. We don't have to change our code as a developer, but now we get the benefit of not having to reload this page each time the form is submitted. And it can do other cool things like retain DOM elements as well. So let me show you that again from the perspective of another framework, and we're going to go back to Blazor now. And this will allow me to show you that it's not just about performance, but it's also about practical user experience details as well. So let's go back to our search form here, okay? And you might have noticed that I've got this advanced option up here. And when I open that, I can now search for coffee at specific locations, like yummy crime coffee. Here we go. All right, so here's some nice crime coffee. But notice that the advanced checkbox has become unchecked. Why is that? I didn't uncheck it. Who did it? Let's try again. I'll open it and I'll click submit. And oh, it just becomes unchecked again. That's kind of annoying. Is it a bug? Well, it's not really a bug. It's because each time we submit this HTML form, it's going to throw the page state away and create a new page. And it, you know, by default, that box is just unchecked. I could write a bunch of code manually to keep track of the state of that, but that's a pain. I'd like to do this in an easier way. And enhanced navigation gives us a way of doing that. So let's go over to the code for that. All right, here is my search form again. Remember, we saw this earlier. And in Blazor, the syntax that we want is data-enhance, which you have to spell with a H. All right, and that is going to tell Blazor that, yes, even though this is a server-rendered form, I want you to progressively upgrade this to execute client-side if the script's available. All right, so now let's reload and see what happens. Okay, so I'm going to open my advanced box, and I'm going to click submit. And you'll notice that this time it does not uncheck itself, because we can mark specific parts of the page to preserve their state across these enhanced navigations. And just for completeness, I'll show you, we're doing 14 requests when this page first starts up. But if I submit the enhanced form, you see it only does exactly 1 request. It's just doing a single fetch request with the data from that form, and then updating the UI in place. So it's more efficient. All right. Now, once again, it is not magic. It's a thing that you could just implement yourself if you want to. So since you're an advanced bunch, let's have a go at doing that, even though it's a bit of an advanced thing to do. We'll implement our own enhanced navigation. Right, so what I'm going to do is, firstly, I'm going to get rid of the enhanced navigation that Blazor provides. So this is the standard blazor.web.js script that implements all this stuff. Let's just delete it, even though I strongly don't recommend that normally. Now I am back to having a plain server-rendered site that's got no enhancements at all. And I've got these other pages. I can navigate around between my other pages, okay, and that still works fine. So I've got this chat. We'll look at the chat more in a minute. Navigation is working fine, but this is just traditional HTML navigation where it's throwing away the entire page each time I click a link. So you can see I've done these 12 requests here. When I click on the chat link there, it's now done another 12 requests because it's thrown everything away. Let's implement our own progressive enhancement, shall we? We can do this with a little bit of script that's not too difficult to understand. Okay, let's get the right one. Okay, so firstly, we'll add a bit of JavaScript that intercepts any clicks, and we'll say, was that a click on a link? If it was a click on a link, then instead of letting the navigation happen, we'll prevent navigation, and initially we're just going to do an alert that says what link you clicked on. Okay, let's go back over here and reload. And now when I click in random places, it does nothing. But if I click on a link, it says, oh, you clicked on a link to /merch, but it hasn't updated the URL, look, it's still on chat. That's because I call prevent default. Right, so let's make this work a bit more. Firstly, I do want to update the URL. And so I'm going to do that by calling history.pushState. And then I'm going to say I want to do my own enhanced navigation to this destination. All right, and my own enhanced navigation is going to look like this. I'm going to say do a fetch request to that URL to get whatever HTML was there. We'll read it as HTML text. And at first, we're just going to alert it onto the screen. Right, let's try that. So when I click on the merch link now, notice that the URL does update, but it doesn't update the actual UI. It just alerts the contents of the HTML that's coming back from there. Okay, so let's update the contents of the DOM as well now. I'm going to do this in a really naive and basic way. A real implementation would probably be more sophisticated, but I'm just parsing the markup that comes back from the server, and I'm just overwriting the entire document body with that. So let's try that out. See how that goes. And now, as I navigate, you'll see that it does update both the URL and the contents of the page, but without doing full page loads. So if we look inside our network tab here, let's clear the number of requests back down to 0, and then I'll click on this merch page here. You'll see we've now done exactly one HTTP request, which is a fetch request for that merch page, and everything else is updated. Okay, so it's not magic, it's not that clever, it's a pretty simple thing that you could do yourself, and it just means that your code, your server-ended application can be upgraded to feel a little bit more responsive to the user. Okay, now let's just get rid of all that stuff that I've done, otherwise it's going to break the rest of my demos. Okay. Right, final thing that we're going to look at just now, interactive islands. You probably think that we've already talked about this because that's where we started when we looked at the Next.js application and I showed you adding this clock and we made it interactive. But I want to show it to you from the perspective of a couple more frameworks. So firstly, I'm just going to complete the story for Blazor and show you how it works there. And then I'm going to show you how it works in Astro because that's a bit different and I think that will be interesting to see the comparisons. All right, so for the Blazor application, I've got this chat page right here, okay? And like I keep saying to you, this is not an interactive application. It's just server-rendered HTML. So as I start typing stuff in here, let's go to this one. I'll say, yes, the cup was empty. Okay, and notice that this number of characters remaining is not updating while I type. We'll fix that in a minute. When I press send, it does send, and it does update the UI. That's because it's just an old school HTML form. It sends it to the server, it reloads the whole page, and it renders the current chat thread into there. So that's how that updates. But if I had 2 people on this site at once, like let's say I'm here with a different browser at the same time, and I type in another message, no, it wasn't. And I hit send. Well, it updates in this browser window, but it doesn't update up here. Because why would it? You know, it's just a static HTML page. It's not going to update until this user manually reloads. But we can fix that by upgrading a particular island of our site to be interactive. And like I said before, Blazor supports both WebAssembly and server via WebSockets modes, and we can enable those forms of interactivity for any page or any component subtree in the site. So let's go to our chat thread component. This component is designed to work in both server-rendered or interactive modes. In fact, all Blazor components work in server-rendered modes to some extent because they just render their initial HTML, and that's what you get. So in this case, when this thing starts up, it gets all the messages from the chat service, and then it's got a bit of logic that emits markup for all those messages. So that's all it has to do in a server-rendered mode. But if we were interactive, we could do stuff like when there's a keystroke. We've also got this subscription to the chat service that will tell us to re-render if new chat messages come in. That's not going to do anything in a server-rendered mode because the component will just be disposed straight away. But I'm going to turn this into an interactive component by adding a render mode, and I'm going to say interactive server. I could also say WebAssembly, I could say auto, which switches between the two based on whether the resources are cached if I wanted to. But anyway, I'm going to use server in this case. And now, even though the rest of my site is server rendered, this one particular part should now be fully interactive. So as I type, hey, you can see that the number of characters is updating on each keystroke. And if I have multiple windows open, then it's going to update the chat in all the windows because it's got a live connection to the server via WebSockets. All right? So that's pretty much what you probably would have expected if you know any Blazor. But let me show you this now from the perspective of Astro, because Astro is unique among all these frameworks in that it isn't tied to any specific client rendering technology. Okay, Astro started out as a simple static site renderer with a bit of integration for client rendering. But in the current versions of it, they've now got server rendering and various forms of progressive enhancement and the ability to interact with multiple client rendering technologies. So let me show you that. It allows us to do some stuff that we wouldn't have done in the other frameworks. Let's clear up here a little bit. And I'm going to start my Astro demo, which is there. Okay, now I haven't made any cute example here. This is just the default project template again for Astro. Okay, so this is what you get by default. The only thing I've added is this link here for exciting counters. And if we go in here, you know, it's going to prompt me to add some counters because everyone loves counters in their web development demos. Let's look at the source code for that. That's inside here, and here, and here. Right. Now, what is this syntax here? Is this React? Is this Vue? No, it's none of those. It's just Astro's own built-in HTML templating and component system, which only supports server rendering. So this is just plain server-rendered HTML. But notice in this components directory over here, I've also got a React counter and a Vue counter. As you can guess, the React counter is implemented in React here with these hooks and on-click. There, and the Vue counter is pretty much the exact same thing but implemented in Vue. So those are just two different client rendering technologies. And now on my counters page, if I want to, I can add a React counter. And you can see the tooling has automatically imported that for me there. So I'll press save, come back, and I've got my React counter now, which is server rendered. And if I click on this increment button, it does not do anything because it's just server rendered. Okay, we'll fix that in a sec. What about adding a Vue counter as well to see that we can have two different client technologies as well? Well, yeah, that also works, and it also does not work because, again, these buttons aren't doing anything. It's not sending any code for these components into the browser by default. If I want to do that, I would go here and I would say client load. And now it will send the code for the React counter and see that will actually work, but the Vue counter does not. So let's fix that in the obvious way. And now the Vue counter also works. But this means, since we're using multiple client technologies, we can even do some quite weird stuff. Like, inside this React component here, I've given it the ability to render any children that are passed into it. And I did the same thing in the Vue component as well. So if I was feeling a little bit weird, I could, for example, put a Vue counter inside a React counter, and it just works. Okay, so we've now got Vue running inside React. And if I was really, really crazy for some reason, I could even then place a React counter inside the Vue counter, and we've now got React inside Vue, inside React, inside Astro, and it all just does the right thing, which is pretty nice. Okay, so that hopefully gives you a bit of an overview of what these kind of technologies are doing now and how these client rendering frameworks are trying to make a move onto the server to take advantage of the performance of server-side HTML rendering, but without giving up on the benefits of client-side performance and interactivity. Okay, so that's all I'm going to say about that. Let's move on now to talk about some slightly different stuff on the server. Okay, so WebAssembly is normally associated with the client, with running in the browser, but you probably know that WASI is a way of running WebAssembly on a server, and various people have been saying for some time, hey, this could be the future of how we do server-side cloud programming. But is it really? Is that going to happen? Well, let's try and understand a bit about what's happened so far. And again, we're going to do this with a timeline. It's a shorter timeline in this case because WebAssembly hasn't been around for that long. The original idea started in about 2015 and it landed in browsers in about 2017. So that's a pretty quick turnaround to get from idea to in all your browsers in a couple of years. And the original idea for WebAssembly was something like this. So you've got some code, and let's say you want to run it inside a browser. Now, if your code is JavaScript, great, you can just run it in the browser already. But if it's not, we need some other way. And so WebAssembly said, well, let's have some kind of bytecode format that can run inside browsers. And we can compile to that bytecode format from whatever language we want, and it will just work inside the browser. All right, that sounds good. But what can that code actually do? Can it format the user's hard drive? Can it access their GPU directly? Well, security is obviously a very big concern. And so the decision was, this is going to be extremely sandboxed. And the only thing that it can do, the only way it can interact with the outside world is by making calls into JavaScript. So at most, it can only do what JavaScript can do. If JavaScript lets it happen, then WebAssembly can do it. And if JavaScript doesn't, then it can't. Okay, so that's how things have been working with WebAssembly in the browser, and that's great. But a couple of years later, people came up with this idea of, hey, WebAssembly is really cool. Wouldn't it be nice if we could use it for our server-side cloud programming as well? Because then we'd have a sort of universal binary format. It would be independent of any particular CPU type. It would be independent of operating system, and it would just work everywhere. That would be magical, right? But what could this code actually do? Well, it was already possible to run WebAssembly on a server, just like on the console, but it couldn't really do anything because, you know, it can't call out to JavaScript. There's no JavaScript running in your server. What can it do? So that's what WASI came along to solve, WebAssembly System Interface. And this defined a standard set of APIs that you could call from your server-side WebAssembly code to do things that are useful on a server. And it was designed around POSIX APIs. POSIX is an API layer that's used a lot in Linux. It's also available to an extent in Windows. And it provides a standard set of things for working with things like file handles and clocks and stuff like that. Okay, and it was a sensible choice to design it like that for the first version of WASI, because at that time the goal was, let's just get existing code to work. So we need existing code that already assumes POSIX. It should just work if we support those kinds of APIs. And that made sense at that time, but this is not the future. It's not the future of WASI. There are some big problems with this form of design. 3 problems, in fact. So the first problem is that this is not really how we want modern cloud-based programming to work. Okay, so in the modern era, we don't talk so much about files. We talk more about things like blob storage or key value stores or distributed queues and these sorts of things. These are our actual primitives that we want to work with these days. A second problem is that this is a very slow standardization process. Each time you want to add something new to this spec, you have to spend years going to meetings, talking to committees and trying to persuade them that it should become part of the standard. And in fact, we're still waiting for the networking APIs to land in WASI Preview 1. That's how slow it is. Okay? And the third problem is that it's not extensible in any way. If you want to do some specific stuff for your application and make it into a standard, well, there isn't really any way of declaring a new WASI standard for your application or your cloud service or whatever. So that's why this is kind of not the future. So what's the next version of WASI and how is it going to change this? Well, the Preview 2 of WASI is built around this concept called the component model, and it's designed to overcome those limitations. So let's have a look at how that works, and we'll try and build something with it. Right, so the WebAssembly component model is built around this idea of an interface definition that's independent of languages. It uses a file format called WIT, WebAssembly Interface Types. And it looks a bit like this, for example. So let's say that you are building some sort of e-commerce site. You might want to define an interface called ordering, which has got a data type in it called product with some fields in that. And you might define an operation called add to cart, which takes a product and returns some kind of result. Okay? That's something that you've defined, and it's not tied to any specific language. It's a language-independent interface definition format, which is a lot to say. Okay? And this can be used for a lot of different things. Okay, so this can be used to define newer WASI standards. So we've got things like WASI HTTP, WASI file. These are defined using WIT, and the standardization process can move a lot faster because each of these things can progress independently and be versioned independently. All right, secondly, you could use these WIT files to define things that are specific to particular cloud technologies. So you could have a WIT definition for the Azure Key Vault service or for AWS Lambda, that kind of thing, and they could be published by different cloud services. And finally, you could define your own WIT specifications for things in your applications, like the catalog thing that we just showed a minute ago. Okay, so when you've got these things, what do you then do with that? Well, you can combine the WIT file with some code in whatever language you want and compile that to a WebAssembly component that satisfies this WIT definition. And you can either import stuff from that WIT file that you can call, or you can export stuff from it so that other people can call you. All right, so then maybe you write some code with some other language as well, with some Rust to make another component, or with some .NET to make another component. And if these all agree about what WIT specification they're working with, then we know for sure that they can all work together at runtime, and it's actually going to work. Okay, now this is not just about interop across languages. That's been a problem that's been solved in many ways over the decades. This is about using the benefits of WebAssembly here as well. So as well as working across different components, we also get the same strong sandboxing. While all three components are working together, they're still independently sandboxed. So when you take a dependency on something, you don't really have to trust it, okay? You don't have to trust that it's not going to read your memory or poke bad bytes into different bits of your buffers. You don't have to trust whether it's going to access the file system or whatever. Each component is still independently sandboxed, even though they're able to talk to each other using the protocols defined in those WIT files. Right? Now let's make this a little bit easier to understand by making some WebAssembly components ourselves. And the example we're going to use, just because it's easy to understand, is Markdown formatting. Let's make a command line tool that takes in some Markdown file and spits out the corresponding HTML. And we're going to do it with a set of WebAssembly components. So firstly, we're going to build the command line tool itself in Rust, compiled to WebAssembly, but we won't implement Markdown formatting inside Rust. What we'll do is we'll define Markdown formatting in a WIT file, and we'll import that so we can just call it, even though we don't have an implementation. Now, we need to provide an implementation, so we'll write an implementation in Go, and we'll export that using the same specification, and we'll see that those things can work together. And then just to show that this is not specific to Rust or Go, we'll also implement an implementation of the same thing in C# and compile that to another WebAssembly component. And again, we'll show that all the stuff just works together. Okay? Right, now let's go and have a look at some Rust code then, because we're going to start building our command line application. You don't need to know Rust, because this is very simple. Okay, all we're going to do in our Rust code is we'll print a big block of stuff so you can see it's running, and then we're going to read in some content from standard input. So I can either type stuff on the console, or I can pipe a file into it, and that will get read into this variable. And then initially, we'll just emit it back to the output. Later on, we'll do some actual Markdown formatting. Okay, let's start by compiling that to WebAssembly. Okay, and I could do cargo build and all that stuff to compile Rust, but there's a few flags I need, so I've just got a script that's going to do that build, and that's going to produce my binary now, hopefully, on disk. So if I have a look, then we should see that this is the file that we've generated literally just now. Okay, and I can run that. It's a WebAssembly file. I could run it in any WebAssembly runtime. I'm going to run it in WASM time, and we'll see it prints out that message, and I can type stuff in, so that's the standard input. And when I finish, it's going to say, oh, that's what you typed in. Great. And of course, I can also pipe files into it. So I've also got an example markdown file here, and I could, let's see, can I pipe that in? Yeah, so I'll pipe that markdown file in, and it will just spit out the contents of the markdown file. All right, but we don't just want to print it out, we want to actually call another component to do some formatting. So we want to start by defining that in a WIT file. And I've got a WIT file down here, markdownformatter.wit, that I've just made up. And it's got this function defined in it called format as string. And we can take parameters. So I'm saying, what output format do we want, HTML or docx? What input are we getting? And then we'll just return some string from that. And then we've got this weird stuff down here called worlds. Very strange terminology. But basically, when you consume a WIT file, you say, which world am I in? If I'm in the world of being a host app, then I'm going to import format interface, which means I can call it. Whereas if I'm a formatting library, I will export the formatting interface, which means that other people can call me. All right? Now let's have a go at using this format as string from the Rust code. Now I have to remember which snippet this is. Something like this one. All right, so I'm calling format as string, okay? And initially I get these red squigglies saying, what are you talking about? I don't know what format as string is. Okay, so I need some way of connecting it to this WIT file, and different languages do this in different ways. In Rust, there's a way of doing it like this. So there's a macro called generate that's going to generate bindings from the WIT files that I've referenced in my build config file. So now I've still got squigglies, but they're different ones. They're now saying, hey, I could import this for you because I now know what this is. So I'll import that. I'll also import output format as well. So that has just generated this use thing, which is importing all this stuff that's been generated. And now, if I build again, so like that, then we will now get an actual WebAssembly component that uses that WIT specification. And if I try to run it now, it won't actually work. It will say, I'm sorry, I don't know what you're talking about. You're trying to use this thing called Markdown Formatter, but you haven't actually provided an implementation of that. And we can get a little bit more information about that as well if we want to. So here's our WebAssembly component, and I can use some tooling called, let's see, this. Okay, WASM tools component WIT, and that will output the WIT specification from this individual component. So it says it exports the ability to run. It also imports a bunch of standard stuff from WASI to do with being a console application, but it also imports this markdown formatter. And that's the unmet dependency that we need to resolve right now. Okay, so we've got our command line tool in Rust. We're now going to provide an implementation, and we'll do that in Go. Right, let's find our Go code. It's over here. Right, you can see my Go code doesn't do very much right now. It just prints a message to the console. And I can compile this to WebAssembly pretty easily. Let's do that. So I'm going to go into my Go code. And again, I've written a build script just so that I don't have to remember the command line arguments. And when that does the right thing, then, oh, actually, it's going to fail because in my build script, I passed some flags saying, hey, you are going to export something defined in this WIT file. And I haven't actually done that yet, so of course I get a build error saying, hey, you didn't export the thing that you were supposed to export. So how can we do that? Well, there's a tool that's designed to work across multiple languages called WIT bindgen. And WIT bindgen says, okay, which type of language do you want to generate code for? In this case, it's TinyGo. What code are you generating? I'm generating the formatting library based on this particular WIT file here. So if I execute that, it's going to generate a bit of Go code, and I'm going to be able to use that to satisfy this interface. So now back in my Go code, it's generated all this stuff. It's quite hard to read, especially if you don't know Go, which I don't really. So I'm not going to try and understand that. I'm just going to make use of it to provide an implementation. So let's do this. Okay, so I've implemented my WIT-generated code here, and I'm saying that I'm providing an implementation of Markdown Formatter, which is this struct, and that struct has got this function on it called format as string, and it just says hello from Go, which is obviously fake right now, but we'll just go with that for a minute. All right, so if I call build again, this time I should not get a compile error, and in fact, in our directory here, we had only one component before, but now we've got two. we've got our Go component as well. And I can run these two things together. The command for doing that is a bit hard to remember, so again, I've made a script which is going to combine the CLI, which is the Rust code, combined with our Go implementation, and it's going to feed example.md into them, and these two components will work together, and the Rust will be able to call into Go, and everything just works. All right, so that's not a bad start, but it still doesn't actually do markdown formatting. Let's do that for real now, shall we? So here's my full implementation. Let me just start that building because it takes a while. And what that does now is it imports all this markdown stuff from Go package management, and it's got this actual implementation where it parses the incoming stuff, it creates an HTML renderer, and then it actually renders and produces the output from that. Okay, let's just wait for that to build. There we go, it's done that. So if I check my directory again now, you see the file is quite a lot bigger because it now includes all of this markdown formatting stuff, but hopefully it will now actually work for real. So if I run that, you'll see it now actually does format my markdown to HTML. All right, so that's good. We've got two WebAssembly components working together. But I also promised you that I would show you we could do the same thing with C# to also generate WebAssembly Preview 2 components using some experimental stuff. Right, so over here, I've got Visual Studio. I've got a project called .NET Formatter. And you may notice a slightly odd thing about my project is that it doesn't contain any files whatsoever. It's completely empty. But I have set it up to target the WASM build target. And I've also referenced these packages that allow it to generate native WebAssembly code. It's a slightly different way of building to WebAssembly that you might have seen before. But the point of that is that when I do build that, let's do a rebuild, you will see that it actually does go through this slightly extra phase now where it generates some native code and it eventually produces some actual WebAssembly file on disk. Okay, that's good. But it doesn't do anything yet. I want to make it use this WIT file. So how can I connect my .NET code to that WIT file? Well, it would be really nice if I could use WIT bindgen again, because that's kind of how these things should work. But that's not implemented yet. So let's just get into the right directory. All right, so I can't use WIT bindgen because it doesn't support .NET yet, but we are talking, and maybe it will support that in a little bit. It would also be nice if we had some tool like this, .NET WIT, that maybe you could point it to a particular WIT file and it would generate some code for you. Now that does not exist either. This is just some sort of hacky internal prototype, but you get the idea of how it could work if we implement support for this. So what I've just generated there is I've got this WIT generated folder, and that contains this interface now, which has been generated, and it looks a lot like that WIT file, but now expressed in C# terms. And ideally, all this WIT generated stuff would be hidden away somewhere, but it isn't right now. And then we've also got this format class, which right now it just throws a not implemented. Okay, but that's a decent starting point. Let's rebuild that and see if we can use this with our Rust CLI application. So now, in our out directory, we've got a third component, which is our formatter.net, and I am going to run this. I'm going to run CLI WASM with formatter.net, and now, well, it doesn't work because obviously it throws the not implemented exception, but you can see at least that it tried to call it. Okay, let's fill in a real implementation. Well, I've already referenced this open source library called markdig, so I can trivially, as a single line of code, make a call into markdig to format that stuff into HTML. And hopefully we've then got a fully complete implementation of our WebAssembly component. Let's go back over here. And we'll try doing the same thing one more time. And you'll see now we do get our Rust code calling into .NET. But we didn't have to change our Rust code in any way. The same component will still work perfectly well with a Go dependency, if that's what we give it, because it's now working across languages, even though each part of the system are still sandboxed from each other. So there we go. What is the point of all that then? Let's try and summarize. Well, the point of this is that we can now use WebAssembly as a general system of server-side components, and we don't have to care what language we write stuff in. We don't have to care what language our dependencies are written in. You could even imagine some sort of future package manager, which would be like a universal package manager. Today, we've got package managers like NPM or Cargo or NuGet, which are tied to specific languages. But you could imagine one that's based around WIT, where all the components in it, you can use them no matter what language you are trying to write code in, and you can contribute no matter what language you're trying to write code in. So that would be pretty cool, right? And then, of course, we can run them in the cloud at high speed with full sandboxing and so on. So that's the idea of WASI Preview 2, which is hopefully going to be landing over the next 6 months or so. So there we go. That's all we're going to have time for this morning. I hope some of that has been useful to you. That's just a perspective on how web UI frameworks are changing over the next few years and how WebAssembly is trying to change on the server over the next few years. I hope you enjoy the rest of the conference. Hopefully, I'll see some of you around. So yeah, that's it. That's all from me. Thank you very much.
Good morning, everyone. Welcome to the Friday sessions of NDC, the last day. Thanks for sticking around. I know as these multi-day conferences go on, the attendance seems to drop off. So, thanks for sticking around so long. And specifically, thank you for coming to this session. In this session, we're going to be talking about the top 5 ways to make the worst microservice system ever. And hopefully with the clickbait title, you kind of got the idea that this is going to be a bit of fun. We're going to have a good time. Some of us will laugh. Some of us might cry as we see parts of our systems in these techniques. But hopefully it'll be a good time. I'm very passionate about building bad systems, so I hope that some of that passion comes through and energizes the room a little bit, so that maybe if you spent a little too long at the cocktail party last night, you'll leave in a better mood than you came in at. I quite like this picture as a visual representation of microservices. The contrast isn't great, but it's a gentleman on a scooter, and you can tell he's going really fast because there's a motion blurred background behind him. Just like microservices, they let you move fast and you can be agile and you can respond to changes. You'll also see that he doesn't have any bloat on him. He's only got the essentials, his shoes, his clothes, his backpack, his hair that I'm totally not envious of at all. But he doesn't have any bloat on him, such as, I don't know, knee guards or elbow pads or protective headgear of any kind. And that in conjunction with his high center of gravity and the low pivot point of the scooter means he's only one bump in the road away from permanent brain damage, just like microservices. So who am I, and why am I qualified to talk to you about building bad systems? My name is William Brander. My friends call me William, and since we've known each other for so long, we're all friends here now, so you also get to call me William. As you can see from the mug, I am the world's okayest programmer. There are unfortunately 3 things that I don't like about that mug. The first is that the A in program is tilted just a little to the side, just enough for me to notice when I'm drinking my tea or coffee. The second is that the font is dangerously close to Comic Sans, but it's not actually Comic Sans, because that would be cool in a sort of ironic way. This is just a cheap knockoff font. And the third is that unfortunately the mug is unverified. I know it may come as a surprise, but there was not in fact a worldwide programmability survey done where they assessed the ability of every programmer around the world and decided I was the okayest. Unfortunately, that didn't happen, so even though I'm in possession of the mug, it doesn't confer upon me the official title of world's okayest programmer. So to look for some more evidence of my okayness, I went to see what my coworkers were saying about me. And as you can see in our company Slack, they don't think I'm the worst programmer at least, but they definitely don't think I'm the best programmer. But what does being an okay programmer have to do with anything? Well, being okay means that I've written some good systems and some bad systems in my career. But I'm pretty sure we all think that we've written some good and some bad. Does anybody think they've never written a bad system? If you're hiring, now is the time when you need to look for hands, by the way. There's a couple in the back there. So what do I bring to the table? What can I offer you that will elevate my expertise in building bad systems and take it to the next level? Well, that's got to do with who I work for, and I've got to be very careful how I phrase this, because just because I work for them doesn't mean that we write bad systems. I work for a company called Particular Software. And Particular Software makes NService Bus, which is a framework and corresponding set of libraries and tools that help .NET developers distribute their systems. So whether you want to do that to achieve microservices, or you want to do high availability, or service-oriented architecture, whatever the reason, NService Bus can help .NET developers do that successfully. The thing with working for Particular is that there's no distinction between the engineering team and the support team. So if you work on NService Bus, you support NService Bus. And I do a lot of support because honestly, it's one of the more fun things that I get to do in my job, because you get to see a lot of different types of systems applied in a lot of different environments, in a lot of different ways, and a lot of different scales, with, one might think, a lot of different quality levels of each of these systems. But here's the thing about system quality. If you assume that the quality of systems around the world, so we take all the systems around the world and we rank them in terms of quality, you might think that it would follow something like a normal distribution, where on the one side, you'd have very few systems that are exceptionally high quality. These are pristine works of art. We should be preserving these systems and studying them for decades to come. On the other extreme, you might think there'd be a few systems that are absolutely atrocious, and we should probably be studying them for decades to come as well, but for a very different reason to those. And then you would think that most systems sort of fall into the okay system quality category. But when you're doing support, the people that have got the good systems don't come to you and ask for help because they don't need it. Everything's going great. The people that have got the okay systems don't come to you very often for support because generally things are just going okay. You know, they're doing just fine. So the types of systems that I see when I do support are the ones down here. The ones where there have been some bad decisions that have been made. The system has been architected poorly. Things are going wrong and they need help. And after seeing a lot of these types of systems, eventually you start picking out some common themes among these systems. And that's what we're going to talk about today. In fact, because I only see systems in this section of the system quality graph, as far as I'm concerned, the distribution of system quality doesn't look like this. As far as I'm concerned, everything is skewed down to the awful side, and we should feel ashamed as an industry of what we're doing to our customers, especially given how much some of us are able to charge them. So microservices, right? Why do we microservice? Well, the consultant answer is we would do microservice so that we can have independent deployability, we can have increased scalability, we can decrease coupling, we can blah, 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 blah. Nobody does microservices for those reasons. We do microservices because we don't want to do a monolith. Somehow, as an industry, we have convinced ourselves that the two options are either microservices or monolith, and on top of that, monolith is bad. That's like saying, well, okay, which color are you going to use to paint, the black or the white? Ignoring the fact that there's many other colors out there, and even if there were only the black and white, you're also ignoring the fact that you can blend the black and the white together to achieve many shades of gray in between. It's not a one or the other discussion. But somehow, as an industry, we have collectively decided monoliths are bad, and you're only doing monoliths or microservices, nothing in between. Go progress. Some of these other answers are quite fun, though. So why do you do microservices? Because you want to increase complexity and decrease performance. That's very, very often the case. It seems like sometimes we're coming up with the most convoluted, complicated way to render little angle brackets down to a browser for HTML. Someone wants to mend their broken heart. Maybe your heart's been hurting. I don't know. So this picture on the left-hand side is a picture of the Kailash temple in India. It is carved from a single rock, making it the largest official man-made monolith in the world. Here's another image of it with a slightly different angle. You can see on the right-hand side, there's a few people standing there to give you an idea of the scale of this thing. This is a phenomenal work of human achievement. Like they had to carve this by hand. Well, I mean, not by hand. They didn't claw away at the rocks with their fingers. They had tools, but not like pneumatic tools or electric tools or anything like that. So this is a phenomenal bit of human achievement that we've done. The amount of work and dedication that it must have taken to construct this monolith is amazing. The ERP system that you've been working on for 10 years doesn't even come close to the scale of engineering needed for this. They had to design this in order to construct it, they had to start from the top down. They had to carve everything away from the top. Everything had to be planned in advance. This is an amazing feat of human engineering that we've got here. Monoliths can be beautiful. It must have been a labor of love, except for the people that worked on it. They must have gotten real sick of chiseling away after the first 5 minutes in the hot sun. Also, I can't help but wonder what this would have looked like if it was built using Scrum. I guess we'll never know. So for the rest of the talk, we're going to work with a single example, and we're going to see how bad we can make this example. So we're going to start with a monolith. All right, and we're going to transition this monolith to microservices, and we're going to see how bad of a system we can get by taking this to microservices. And we're going to see if we can make this an awful experience to work with. Spoiler alert, it's pretty bad straight from the first technique, but we can get it really bad later on. So because it's a monolith, remember our earlier discussion, monoliths are bad, so this must be a tire fire that we're working with. Now, the first technique we're going to use to transition away from the monolith into microservices is something known as the strangler fig pattern. I'm pretty sure most of us have heard of the strangler fig pattern by now, but if you haven't, what the strangler fig pattern says is that when you want to transition something to microservices, you start by carving off bits of functionality. And once you've taken that functionality, you can then extract it out to its separate service. So we'll isolate a bit of internal functionality, maybe something like the charge credit card service. Once we've isolated that within our monolith, we can then take that functionality and move it to a separate microservice, and then we can call that microservice instead of calling the code directly. And at this point, we can pat ourselves on the back because we have now achieved microservices, and we can order a pizza party or whatever business is doing for us these days to celebrate successes. But what have we actually done to our system performance? So let's take a look at a graph. And what we'll do is we'll look at the throughput of the system and how it changes based on the load of the system. And we'll first start with the monolith. So this is before we make any changes to the system. As we increase the load of our monolith, we should expect the throughput of the monolith to increase at a roughly linear rate. Now, I don't mean one-to-one. When I say linear, I mean like some k value, probably between 0 and 1, where as you increase the load by 1, the throughput will increase by X amount or K amount, whatever that is. As we increase the load even more, though, there's a higher chance that there's going to be contention of resources. There's going to be more swapping of threads because it's taken a little bit longer for things to complete. We're doing more things per time unit, but each of those things is going to start taking a little bit longer. Maybe there's row locks that we've got. There's contention on resources. So we start seeing a sort of tapering off of the increase in the throughput of the system when the load gets to a certain point. At some point, though, if we increase the load of the system too much, we're going to see the throughput completely drop off. Why? Why would you expect this to happen? So I'm a .NET developer, so what I'll do is I'll explain why this would happen in .NET. But this will work, or this will apply regardless of what language you're using. If it's a managed runtime environment where they do some type of garbage collection for you, something like this is going to occur when your systems get to a certain amount of load. So in .NET, there are 3 types of garbage collection events: Generation 0 garbage collection, Generation 1, and Generation 2. And .NET makes a few assumptions around garbage collection that it builds its garbage collection methodology off of. So if .NET decides it needs to do garbage collection, the first thing it does is decide what type of garbage collection do I need to do. And that's because the assumption is that variables that are assigned to the heap are very quickly released or can be released again shortly afterwards. And they represent that by doing a generation 0 garbage collection event. So as soon as you create a variable, var a equals 1, 2, 3, .NET will go and assign that bit of memory to the heap. And it puts it in the generation 0 category. So when a gen 0 garbage collection event runs, it goes through everything that's marked as generation 0 and says, well, is something still referencing you? No, I can release you. Is something still referencing you? No, I can release you. If it gets to 1 that's still being referenced, it then takes that generation 0 memory and promotes it to generation 1. So it's not going to release it, but the assumption here is that generation 1 is going to run less frequently than a generation 0 garbage collection event. And if you're still using something while I'm trying to clear up memory, it's probably going to hang around for a little bit longer. So as our system takes longer to do things, things hang around longer, which means we're reserving that memory longer, which means that the higher likelihood that those things are going to get promoted to generation 1. If things take even longer and a generation 1 garbage collection event runs, it's going to go through all of the items marked gen 0 and gen 1. So immediately a generation 1 garbage collection event takes longer than a gen 0. But it's going to go through all of the gen 1 items and see, can I release you, can I release you, can I release you? If it can't release it, it's going to promote it to, surprise, surprise, generation 2. And that's sort of where the problem begins. So generation 2 garbage collection events in .NET are what is known as stop the world events. What it does is it pauses all user threads. So if your application is processing 100 different threads, all of those threads are going to be paused except for the one doing the Gen 2 garbage collection event, which means you're not processing anything. Stack Overflow experienced this a few years back, or many years back, not a few. And this is a graph showing the response time of the web servers. These spikes over here that you can see, these are where the Gen 2 garbage collection event was running. And Mark Gravel wrote a whole blog post about how they managed to work around that eventually. Since these days, though, so this was 2011, things have improved a lot with garbage collection in .NET. We've now got the background garbage collection processor, which goes and does this in the background. So it doesn't pause all of the user threads unless your system is under sufficient load that .NET decides it needs to do a foreground garbage collection event, in which case, pauses all user threads, and you'd get a drop-off in performance. So that's why we expect to see this drop-off in performance in a monolith under a certain amount of load. What happens when we transition to microservices? Well, let's start increasing the load of our microservices. At the beginning, we should start seeing a linear-ish increase in the throughput of our microservices. I hope it's obvious that the increase in throughput will be lower than the monolith because we've introduced network operations, right? Network operations are expensive in terms of computing time. It takes a long time to negotiate that TCP connection, to do the certificate exchange, to serialize, to deserialize. So we should see things taking a little bit longer for the same amount of load. Okay, well that means things are going to hang around longer, which means we're going to get more thread swapping sooner, which means that decrease of throughput is going to come sooner, which, surprise, surprise, means the big drop-off in performance is going to come sooner. So the first technique that we can do when we try to make our system as bad as possible, the first technique that we can do is we can actually try and do microservices. So for the first one, you put a network call in front of everything, and that's a guaranteed way to make your system a little bit, just a little bit worse. Is anyone here old enough to remember the WCF days, and there were those people going around saying everything should be a WCF data service? Everything should be a data contract or data object, wherever it was. Yep. Man, what a time to be alive. So we've taken our system, we've applied the strangler fig pattern all over the place, and we no longer have a monolith anymore. We've now distributed our system into a microservice. The thing that the strangler fig pattern is not good at, though, is changing application logic or fixing any coupling problems that you've got. So if you had coupling between code components, you're still going to have that same coupling between your service components now. And in fact, we've made it worse because on top of the normal application coupling that we had, we've now also got network topology coupling, because we can't go and move these services around without telling the other services, hey, we've moved it around. So we've taken our monolith, and we split it up, and we've made it even worse by making it a distributed monolith. So instead of a single tire that's burning, we've got a field of tires that's burning, which is pretty good. So in terms of progress for making the worst system possible, this is a good first step. But now, if you're working on this system, it's going to be pretty bad to work with. You're going to hate your job. You're going to come in, do your 8 hours, and then leave, and probably bang your head on the desk a few times. And you're going to, I'm almost willing to bet, find yourself thinking, yeah, I bet you I could rewrite the system in a few months, and that'd be great. Has anybody ever thought, I bet you I could rewrite the system, and I'd fix all the problems? You're all lies if you haven't put your hand up. So rewriting the system is a very enticing option sometimes, because it's difficult to work with this legacy that you're dragging along with you. But the thing with rewrites is that big bang rewrites of large complex software systems do not work. Asterisk. And we'll kind of circle back to that asterisk in a bit. But rewriting a big, large system is probably not going to be a good idea, and it's probably going to fail. Why is that? Well, that's because of how we do software development. So software development, in its essence, is exchanging time for functionality. You're taking developer time and converting that developer time into features that users can use. So we can represent that as a graph. So on the y-axis, we've got the amount of functionality in the system, and the x-axis is the time spent developing on the system. Sometimes we render this as burn down charts, but it's essentially we're taking developer time and converting it into functionality. And at the start of a system, things are going great when you've got a greenfield system. The amount of time that you spend working on your system means that you get a high output in terms of functionality that you can add. You're throwing new screens out left, right, and center. Your users are very happy with this. Eventually, you get to a point, though, where you need to sort of go back to previous functionality that you've worked on. You have to pay some technical debt, maybe refactor a few things. You've got business rules that now have to interact with previous screens that you've designed. So it takes you a little bit longer to add the same amount of functionality that it would have taken you a short amount of time to do at the start of the system. And eventually, it takes a really long time to add any functionality because there's just a lot of competing different rules. There's a lot of things going on in the system that you're working on. And you might think to yourself, okay, well, this is the time now that we need to do a rewrite. So you go to the business and you say, listen, we've just completed our microservice project. That was a great success. We've microserviced everything. How about as a reward, you let us do we'll call it a modernization project. We'll modernize the system. It's not a rewrite because they won't agree to that, but we'll modernize it. And we'll replace the parts with a new system. Give us 6 months. It'll be perfect. And the business will go and say, 6 months? Okay, yeah, we can make that work. So you start your rewrite. Now, if we started it here, like where the amount of new functionality you can add is absolutely awful, so we timed this rewrite perfectly, what's going to happen is that instead of adding this bit of functionality at the top, because we're not adding more functionality, that no longer exists while we're doing the rewrite. So the amount of functionality we've got stays constant, and then we start rewriting the system again. And now, this is a new system, essentially. It's a greenfield system. So the amount of functionality we can add in a short amount of time is fantastic. This is the most amazing thing we've ever done. And it's probably going to be faster than it was originally because you've spent more time in the business domain. You know more about the business problems that you're going to experience. And while you were working on the old system, you're probably sitting there banging your head on the desk thinking about how you would do things differently. So you're going to be very productive during this phase. But it's going to take you longer than 6 months. Why? because I'm a developer. I know how we estimate things. In fact, there's probably some correlation between how good of a developer you are and how good of an estimator you are. If you're a really good developer, you're probably a really bad estimator. And if you're a good estimator, you must be an awful developer. I myself am the world's okayest estimator. I've got that going for me. But even if you could estimate with 100% accuracy, so if you took the entire system and you knew it was going to take you 6 months to redo this entire thing, it would still be wrong. Because with large complex systems, you can't keep all of that context in your head while you're doing the estimation process. There's a lot that goes on in these large complex systems, and the chances of it being 100% documented is almost zero. It's a bit like with that dog from Up, where we get hyper-focused on certain things at a time, forgetting about everything else. Or every second Tuesday, if it happens to fall on a full moon, the business rule inverts, and now we need to pay customers to use our system for 24 hours. It's those edge cases that make software development interesting, and we often forget about those while we're doing problem solving of big complex systems. So we're busy working on our rewrite, and it's been 9 months now after we told business that it takes 6 months, and they're going to come to us and say, listen, we can't keep doing this. There's a new compliance project coming out. GDPR 2.0 has hit. We need to comply by the end of the year. And you say, okay, just give us 2 more months, it'll be fine. 4 months later, they come and say, okay, this is it. We're canceling this modernization. It's not a rewrite. We're canceling this modernization project now. And you go into the stages of grief, and you immediately jump to the bargaining phase, and you say, okay, I'll make you a deal. Got an idea. What we do is, we'll have the old system that's in production, right? And that's working fine. People are using that. We'll keep that there, and we'll deploy the parts that we've rewritten so far. Does this sound familiar at all to anyone, right? And the users can use the new system for the parts we have rewritten and the old system for the parts we haven't, and then we'll keep them in sync by creating an integration layer. That'll be fine. Yes. And you honestly believe this because it feels right. You've invested 10 months of your life trying to do this rewrite, and you sort of forget that now you don't just have to support one system, you've got to support 3 systems. You have to support your old legacy system, you have to support your new system, and you have to support this horrible integration layer. The integration layer is going to be horrible because it has to talk to the horrible old system. And the longer that it has to do that, the more likelihood there is that the horrible decisions in the old system are going to bleed over into the new system. Oh, William, I need that field in the report by Tuesday afternoon. Please, can we get it in the new system? And you think, okay, well, yes, I'll just take it through as it is now, and then I'll fix it in the next sprint. Yeah, right. But at least we're doing services now. So on the new side, that's great. It's a bit like trying to build an airplane while you're flying it. I asked DALL-E to generate an image of that, and I came up with this horrifying thing. I don't know why it's got the word dogs on the side. I don't know what that's about. And it looks a little bit, I don't know, is it just me or is it the Ryanair font under the engine? No judgment. So the second technique that we can use to make the worst system is we can try and do a big bang rewrite. Now I said big bang rewrites do not work, little asterisk. There are 2 cases where they do work. The first case is when the system is actually just not large and complex. So if you can safely do the rewrite within a few months, it can work. But at that stage, you're not dealing with large complex software systems, you're dealing with a system. Again, you need to sort of make sure that you've checked your assumptions about the estimation, how long it's going to take, whether you can do it within that period of time. But it can work if the system isn't actually that complicated. The second time that it will work is for your CV. So as soon as you start the rewrite, you put the latest and greatest technology in your new project. And before you even compile, you add it to your CV as well, and you start sending that out. And that'll work for you. So where are we now? We've got 3 systems we're supporting in production. We've got the old system, we've got the new system, and we've got the monolith. Cool. It's still not too bad, though. We can make this worse. Let's take a look at this problem. Remember why we had this big drop-off in performance? It was because we were waiting for things to finish. They hang around longer, which means there's a higher likelihood of Gen 2 garbage collection. We don't want to do this again. We want to make new, better mistakes. Making the same old mistakes is boring. So what we'll do is, instead of our service calling another service directly and waiting for a response, we'll be smart. We'll do this thing we've heard about in the microservices space called queues. So we'll introduce a queue at the credit card service, and our service A, when it needs to call the credit card service, instead of calling it directly, it just takes a message and puts it on the queue for the credit card service, which means that as soon as the broker tells our service, cool, I've got your message, service A can then terminate, and we don't hang around for a long time, so we don't get the Gen 2 garbage collection. That sounds great. What could go wrong here? Well, let's have a look at the credit card service. So as this calls our payment service, it takes messages off the front of the queue, and it says, okay, I need to charge this credit card 10 euros. I'll call my payment provider and do that. So our message flows along from the back of the queue to the front, and it gets to the front, and it says, we need to charge William's credit card 50 euros. And we call the payment provider, and something goes wrong, probably because I don't have 50 euros to my name. I don't know. And we get an exception. I think, okay, oh well. Well, we've taken that message off of the queue, and it's now disappeared. It doesn't happen often, but I don't want to say never happens, but it's very rare that I get a business requirement that I need to lose my customer money. But if this was that requirement, I'd be doing a great job here. So instead of just losing that message when we take it off of the queue, what we'll do then is we'll get clever and we'll think, well, when I take the message off of the queue and I try and process it, I'll do it in a loop within a try-catch. So if it fails, I'll just keep trying to process that message. And that's fine. Now I don't lose that message, except maybe there's something wrong with the payment provider. And all I'm doing is I'm DDoSing them constantly because I'm just trying to process the same message over and over and over again. Maybe they charge me per call that I make. Okay, so now I'll get smarter and I'll think, well, what I'll do is I'll introduce some sort of delay mechanism that if it constantly fails, we'll back off and we'll slow down. Okay, so we solve that problem. But maybe my credit card will never have 50 euros available to it and the call will always fail. Maybe I put the wrong credit card number in. That message is sitting at the front of the queue. Everything behind it is waiting for its turn to get processed. But this message that will never get processed is sitting there blocking everything. Okay, well, easy fix. What we'll do is we'll introduce a dead letter queue, and we'll take that message and we'll move it to the dead letter queue, which then also means that I now need to make some software to manage that dead letter queue so that I can put those messages back in production. And this is actually sounding like a really fun engineering problem. And it is a fun engineering problem because it's what I do as my day job. This is a solved problem by NService Bus, Mass Transit, Rebus, Brighter Command. There's many options just in the .NET space that solve this sort of problem for you. And I used messaging as an example because that's what I know, but you can take any sort of example you want here. Did anybody, I don't know if it's still a thing that the young people do these days, but back when I was doing software development, in my day, everybody had their go at writing an ORM mapper. So you would have your little table definition, and then it would generate the SQL scripts to create the table for you, and then it would create your code file so you could just call those things. Everyone did that, right? So whether it's that, whether it's a front-end framework, the chances of your business needing such a unique use case is very slim. I'm not saying it's impossible, but it's very slim. And there's almost always going to be an off-the-shelf framework that does a lot of what you need, even though it's really cool engineering problems to solve. So the third technique is don't use off-the-shelf frameworks to help you do these kinds of things. So what do we have now? Well, we've got our monolith that we're supporting. We've got our new system we're supporting, we've got our integration layer that we're supporting, and we've got this horrible, smelly, buggy framework thing that we're supporting as well along the way. So that's 4 things that we're doing instead of actually doing any business functionality. That's pretty good. Let's dig a little bit deeper though, and we'll look into more specific examples. So maybe this is an e-commerce site that we're working on. It's it's rainforest.com. So rainforest.com is an e-commerce site, and you can buy things. Predominantly products, so we'll have a product service that defines things that you can buy. So maybe something like coffee would have a title, it would have a price associated with it, some images for the product, where it's in stock, a description, some reviews for it. And we sort of build this into our product service. And we end up with an entity that sort of looks a little bit like this. And then our business comes to us and says, we need a search screen. And you go, great. I've been waiting for this moment my whole life. We can take our product entity and create a search screen. So if someone searches for coffee, we get a list of all of these things because we can search through the name or the description of the products, and we can display all things that have coffee somewhere in them. And that's great. See, the modernization project was a success, even though it's not finished yet. But then our product owner comes to us and says, hey, I've got an idea. Now, the correct response when your product owner comes to you and says, I've got an idea is, you tell the product owner, please wait until the next sprint. We can do this during the sprint planning session. You escort them out the building. Once they've left, you fake your own death and you start a new life somewhere else. But you don't do that, and the product owner says, we've got a theory that if someone has ordered specifically consumables before, there's a high likelihood that they'll order the same thing again. So we want to show on the search screen which products a user has ordered before. And you think, oh, damn, that is a good idea. Except the order history isn't in the product service. That's in the order service that you've got. So if you want to display that and you start sort of getting creative and you're thinking of ideas, okay. I'll tell you what, product owner, if you promise that this is the only time this is going to happen, we can make this work. And they agree, of course they do. So now you include the order service in your product services search. Now, it doesn't necessarily have to mean that you're calling two things. Maybe the product service is coordinating this. Maybe you've got a cool API gateway in place that'll solve this for you. But you're now involving data from two different services in your search screen. But it's okay. You deploy this and it's working and everything's great. And then the next sprint, the product owner comes to you and says, hey, instead of faking your own death, you listen to them and they say, well, we want to give certain customers certain discounts. So if they're a gold customer, maybe we want to give them a specific price. And again, you think, damn, that's a really good idea. Can't shoot it down, except the customer status isn't in the order service and it's not in the product service either. That's in the customer service. And you think to yourself, I just fooled myself real good here. You promised, product owner, and the product owner is going to say, well, I didn't pinky promise. So now you include the customer service in your search screen, and eventually your whole system is bled over to having all of your different service boundaries in one request. And search is a good example of this because search involves looking for things all over the place. So it might seem like a contrived example, but search is a hard problem to solve. Just think how much money Google throws at the problem. But why is this a problem? Why do we have these cross-service boundary calls? Has anybody watched this video? There's a slide at the end with the URLs and everything, but this is mandatory viewing if you are going to attempt microservices. It's by a YouTube channel called Krazam, and the video is called Microservices. I cried the first few times I watched it because it's so beautiful. Should have won an Oscar for something. But if we've got our three different services, right? We've got our service boundaries, our product service, our order service, and our customer service. These are nice things because we can represent them as nice little entities. Right? You can go into a shop and you can pick up a product, you can inspect the product, you can look at it, you can put it down. You can do the same thing with the order, like you can take your invoice, your till slip at the end, and you can look at it and you can inspect it and put it down. It's a nice thing. I guess you could pick up customers and inspect them, but I wouldn't recommend that. If you do have to make sure you put them down at some point though. But these are things that you can interact with at a physical level. When it comes to software though, users don't product. They don't customer, they don't user. They search, they check out, they add to cart, they do these processes, they verb rather than noun with your system. And if you take your service boundaries and you define them as nouns, there's a very high likelihood that you're going to have to do cross-service communication whenever you're doing verby things. So whenever you're interacting with the system, when you're shopping, there's a high likelihood that there's going to be cross-service communication. Because doing things isn't just a thing on its own. It's usually a combination of different puzzle pieces. Again, I asked DALL-E for a picture of a puzzle. I'm concerned that it doesn't know what words are, because this is not a puzzle that anyone can do. So, to make sure that we have the best chance of having the most cross-service communication possible, the fourth technique that we can use is we can make sure that we define our service boundaries based off of nouns and not verbs. It's really hard to make your service boundaries based off of verbs, but it is so worthwhile. If you end up with your service boundaries being product, policy, claims, take some time to reflect on those and see if maybe there's different ways that you can represent the actions, the behaviors of those internal service boundaries. Right, so we've got our monolith, our integration layer, our microservice system, this new framework that we support in that's a bit buggy and broken, and we've made sure that all of our services are defined in such a way that they're nouns so that there's as much cross-service communication as we can possibly get. How can we make this worse? Well, let's fix this, right? We want to fix things, not make them worse. So what we'll do is we'll fix this. Instead of having cross-service calls, we'll make this a better thing. So instead of having search being a product thing, what we'll do is we'll create a search service, right? To search is a verb, so this is good. We've got a good service boundary there. And the search service can have its own little representation of the products. So instead of being a product entity, it might be a search product entity, which has some additional fields in there. So whether which customers have ordered this before, specific pricing for specific customers. You know, we can make whatever model we need to represent the search behavior within the search service. And this is looking promising. But how do we get the data into the search service, right? Well, I know, we've got pub sub, right? That's cool. So what we'll do is, whenever a new product is added to the product service, because the product service is the source of truth for products, we'll publish an event. And then the search service can subscribe to that event, and it can maintain its own list of search products. And we can do the same for the customer service. When the customer status changes, we'll publish an event, and we can maintain that list within the search service. And the same for the order service. Publish events when someone orders something. Anybody tried this before? There's so many problems with this. Not least of which is the duplication of data, because that's fine. Like we can justify that away. We're all smart here. We're all architects, so we can say things like, this is okay because the source of truth for products is still in the product service. This is just a read model. Okay, so we're doing CQRS. Yes, this is good. CQRS, we're publishing events, so it's event sourcing as well. We're doing CQRS event sourcing and definitely bounded context, so it's DDD. So we're doing DDD CQRS event sourcing. This is a good thing. This is a fun system to work on. And people believe you. But even if the duplication of data wasn't a problem, which it sort of is, the biggest problem with this is you still have tight coupling between your components. As an example, if the customer service changes its business rules that says, well, instead of giving special pricing to gold customers, we want to give special pricing to the top 100 customers. The customer service makes its change internally, and then suddenly the search service doesn't work because it's still listening for events that says customer status has changed, not, well, customer has moved from 99 to 100. We've got tight coupling between the business logic of the search service and the customer service in that case. So even if the duplication of data wasn't a concern, the coupling is a bigger problem. We can fix this though, and I'm going to show you a technique to fix this, but I want to be clear. I'm not saying this is a good technique. I'm also not saying this is a bad technique. I'm just saying, hey, here's a thing. Put it in your toolbox. If it works for you, great. If it doesn't, also don't just use it everywhere. And the thing that it relies off of is that when you're dealing with software, we've got the 4+1 view of software, right? And it means that the logical boundaries of your system doesn't have to match the physical deployment boundaries of your system. You can have the logical boundaries be intact while breaking that apart at deployment time. So we're going to look at something known as the engine pattern. So we'll first of all replace our search service with a search engine, because that just sounds right, doesn't it? A search engine is much better than a search service. And the search engine is going to expose 3 interfaces. So the first interface it's going to expose is something called iFindProducts, which just takes in a filter and spits back a list of products. It's then going to expose an iPriceProducts interface, which, surprise, surprise, gives you a price for a product for a specific user. And then an iTrackOrders, which just says true or false if someone has ordered something before or not. So the search engine takes these 3 interfaces and compiles it into an assembly and puts it on a local NuGet feed or something, or some type of internal package manager. Which means then that, how do we use this? So our product service can go and take that NuGet feed or that package from wherever it is, and it can implement a class called Product Finder. And this class implements the iFindProducts interface. The customer service can do the same with the status pricer. So the status pricer class can implement an iPriceProducts interface. And the order service can implement an order history class. how do we deploy this? How do we bring it all together without introducing coupling? As part of your build process, when you check in your code, why don't you take that product finder class, compile it into its own assembly, and then take that assembly, that DLL, and paste it into the folder of the search engine. So the search engine, when it says, oh, I need to do a search, can say, hey, .NET, please give me all of the classes in my app domain that implement the iFindProducts interface. So in this case, the search engine doesn't have to know about the product service. It just knows, oh, here's a class that implements this interface. So now I can ask this class for a list of products that match the search text that I've put in. That product finder class knows that it needs to talk to the product service database. And we can do the same with the status pricer. So the status pricer can be compiled into an assembly and put into the search engine's folder. The search engine can then say, give me all of the instances or give me all of the classes that implement iPrice products, and apply that to the list of products that you got from the previous product finder class. And then the same happens with the order history class. We're making 3 queries here, but there's a big distinction between what we had here and what we had with the cross-service communication. Because the product finder doesn't need to know anything about the status pricer. It doesn't need to know anything about the order history. It doesn't need to know anything other than I'm making a query to my database, and here's a list of products that match. If the customer service changes its business rule and says, well, instead of the status given special pricing, we want the top 100 customers to have special pricing, the customer service makes the change logically within its boundary. Instead of shipping out a status pricer class, it ships out a ranking pricer and places that in the search engine folder. The change only happened logically within the customer service, but it's now affected the way that we display results in the search engine. We don't have that same coupling before. So even though we're still making multiple calls to multiple services, logically, those calls aren't crossing any service boundaries. So we have the low coupling that we were looking for there. Another nice side effect of this is that you're not only limited to the product service only doing the product finder. For instance, the product service could say, well, every day I'm going to choose 10 items at random, and these 10 items are going to be heavily discounted. So the product finder or the product service can implement a daily deal pricer and ship that off. So when the search engine says, I need to display the prices, it now gets 2 instances of classes that can change the prices of the products. Maybe the order service wants to do a bulk discount. If someone has ordered 9 of these items before, the 10th one is 90% off. The order service can create a bulk discounter that implements the iPrice products and send that off to the search engine. None of these things know anything about any of the other components. There's very low coupling between them. And all of the changes that have to happen within the service boundaries of each of these things. And the thing that this relies off of is that you don't need to have the same logical system boundaries as you do with the physical system boundaries. You can have those be different. So if you want to make sure that you get it wrong, make sure that you conflate those 2 together so that you don't accidentally deploy things differently. So we've had 5 techniques. The first is just to put an HTTP call in front of everything so we can have a nice, great distributor monolith. The second is to do a big bang rewrite, because what's better than having 1 system to maintain? Well, having 3 systems is better. The third technique is to make sure that we do all of our cool things ourselves, because that's actually the fun engineering work that we want to do. And it is really rewarding for us. It's just a pity that the poor business doesn't get any value out of it. Make sure that you use nouns instead of verbs for your service boundaries. And then conflate your logical and your physical deployment boundaries together for maximum effect, so that you can't work around any of these coupling issues. I'm going to leave this slide up for a little bit while I talk. So I want to sort of pre-answer a question that I often get about this. I finished quite a bit early. But I almost always get a question either directly from the audience, or they come and ask me afterwards of, well, thanks for showing us what not to do, but can't you show us what we should do instead? And I think, unfortunately, that's a bit of a failing in the way that I present this talk. So it should be obvious that the talk is not about what you should do to make successful microservices. But at the same time, and slightly less obviously, it's also not about what you shouldn't do to be successful with microservices. So all of these 5 techniques, I listed them as guaranteed fail, but they're not. Right? They're all very valuable, important techniques. The strangler fig pattern is a very valuable tool that you can use. but it has its downsides. It doesn't help you with any coupling concerns that you've got. It doesn't help you tease out important complex parts of your system. It's really good at taking bits of your system that are well designed and well encapsulated and moving them elsewhere. But you need to get to that point first. Not every off-the-shelf frame or not every problem has an off-the-shelf frame that's going to work. But chances are there's probably something that's going to be valuable there. So when I say these are the top 5 techniques to get things wrong, that's not necessarily true. The intention here is so that we're all smart. We're all in this room. We're at NDC. We're trying to learn. We're trying to get better at our craft. But there's downsides to all of these things. So when you use these techniques, don't be afraid to use them. They're very valuable. But think about what the downside effects are and weigh that up against what benefits you get from it. Maybe it's okay to have cross-service communication because you get a very clear way of talking with your users about the problem domain. Maybe a single language is more important to you than having fewer cross-service calls. Just be aware of all of the side effects, or not the side effects, the downsides of these types of techniques. Rather than building systems that are horrible quality, I don't want to see any systems that you people build. I want to see you guys build systems up in this side of the segment. So you don't have to come to people like me to help you with these things. And with that, I am done. Are there any questions? You can always talk to me afterwards. I'm very, very excited to talk about bad code. So you can grab me after if you want as well. Great. Thank you, everyone. Have a great day.
Good morning. Thanks so much for joining me. My name is Simon Brown. This session is about C4 models as code, which is really, of course, about architecture diagrams and documentation. So architecture diagrams have traditionally been horrible. Lots of random boxes and arrows that look like this, and I'm sure we've all seen whiteboards where we've got diagrams exactly like this. This isn't a tooling issue. One of the things I do is I get to fly around and run workshops for teams, and I kind of force them to use pen and paper or whiteboard. And people ask me, if you let people use a tool, do you get better pictures? And the answer is not really. And you can find tons of these diagrams on something like a quick Google search. UML used to be something that we all used to use for diagrams and documentation, certainly those of us who have a little more grey hair than others. But this all faded out in the early to mid 2000s. Predominantly, I think, because of the Agile Manifesto, but also because the UML specification became too complicated, too bloated for most people. UML fixes a lot of the issues we typically see with bad architecture diagrams, but nobody wants to use UML these days. Why? Here are all the reasons. I've literally had people say these things to my face. If you use UML here, you'll be seen as old and old-fashioned, which is a bit strange. People think UML is not expected in agile ways of working. They think it's a waste of time, it's too detailed, etc., etc. There is some truth in some of these reasons, but most of them are actually just myths. So I created something called the C4 model, which you can find documented at c4model.com. Quick show of hands, who's using C4 here? So that's a small number. So this should be a nice introduction for those of you who are not using C4 yet. So what I wanted to do was I wanted to create a way to allow teams to draw architecture diagrams in a lightweight but structured manner. That's essentially what C4 is. And this is the underlying principle. If you don't want to use UML or Archimate or SysML or those other formalized notations for drawing architecture diagrams, and you want to stick to boxes and arrows, that's fine, but try to do so in a structured way and make sure your notation is self-describing. So I'm trying to solve a bunch of different problems here that I commonly see with architecture diagrams. The thing that sits behind C4 is a set of hierarchical abstractions. The biggest of these abstractions is what I call a software system. A software system is something like a service that a single team is building, or it's typically something that a single team is building, responsible for. They can see the internal implementation details of. So that's something. That's the thing I'm calling a software system. It's something typically owned by a single team. If we look inside these things I'm calling software systems, I'm going to say they are made up of one or more containers. I don't mean Docker. This has nothing to do with Docker. There's an unfortunate clash of naming. I got the name first, but Docker became way more popular, so that's a bit awkward. By container, I basically mean an application or a data store. So the services and the software systems we build are made up of applications and data stores. So this is your front-end app running in a web browser, React, Angular, etc. It's your server-side apps running on a server, so ASP.NET MVC, Spring Boot, Ruby on Rails, etc., etc. There could be a C# console app or a Windows service. It could be a C++ console app, command line app, that type of thing. And from a data perspective, it's a database schema, something in blob storage, an Amazon S3 bucket, a folder on a file share, etc., etc. So the systems we build are made up of applications and data stores. Collectively, I'm calling these things containers. If we zoom in and look inside the application containers, the things that are ultimately built from code, I'm going to say they are made up of one or more components. So by component, I mean this: a grouping of related functionality, hopefully behind a nice, clean, simple, well-defined interface, running inside a container. So in this set of abstractions, components are not individually deployable units. It's the container. It's the application that's the deployable, runnable unit. And if you zoom into an individual component, I'm going to say they are made up of code-level elements. So imagine you are building a component in C#. When you zoom into that component, it's made up of classes, enums, interfaces. The same in Java, same in C++. In JavaScript, this is now objects and functions. In F# and Haskell, it's functions. So that bottom level represents the code level constructs we have in the languages that we're using. So that's it. It's a set of simple hierarchical abstractions. C4 actually gets its name from the diagrams, the diagram types. And in this case, the static structure diagram types. So C4 stands for context, containers, components, and code. So it's 4 levels of diagrams that map onto the 4 levels of abstraction. And what we're doing is we're starting with a bunch of high-level boxes. We're zooming into a box to show the internals of that box. We're then choosing another box to show the internals of that box, and so on and so forth, right down to the code level if you want to. Although C4 has the number 4 in the name, I don't recommend using all 4 levels. The 4 levels are there for completeness. Most teams only use the top 2 levels, the context and the container diagram. And the concept here is diagrams as maps. So I live in Jersey in the Channel Islands. If you open up Google Maps on your phone and you do a search for Jersey, you're probably going to get that picture there. So this is great if you want to know where the airport is in Jersey and where the nice beaches are and where the roads are. If you've never heard of Jersey before, it's too much detail too quickly. How do you fix this problem with Google Maps? You pinch to zoom out to get some more context. If you zoom in further and zoom in and zoom in, eventually you drop down to Google Street View, which is a one-to-one mapping with the real world when the photos were taken. I want to do the same thing with architecture diagrams. I want us to have a collection of hierarchical architecture diagrams that allow us to tell different levels of detail, different stories to different audiences. Think about the last time you joined an existing project and they had like 500,000 lines of code and they just dump you in the code base and say, hey, add this feature, please. That's too much detail too quickly. You need to zoom out to try and figure out what it is we're building here, where it sits in the rest of the environment. So yeah, diagrams as maps is a nice analogy here. I'm going to focus on the top 2 levels of diagrams before we get into the tooling side of this talk, because it kind of helps set the scene for what we're going to discuss later. So the top level diagram of C4 is a system context diagram. In order to draw a system context diagram, you need to answer these basic questions. So what is the thing we're building? What is the scope of the thing we're building? What features sit inside the thing we're building? And what features sit outside the thing we're building? Who is using the thing we are building, the system or the service? And how does it fit into the world around it? In other words, what are the system integration points, the service-to-service integration points? Answer those questions, and you can draw something like a system context diagram. So this is a real example diagram from one of the workshops I ran. The group here have correctly identified this red box is the financial risk system that the group were designing. So this was an upfront design exercise. They have correctly identified 2 types of users, and they have correctly identified the external systems in the organization that we need to have an integration point with. So that's an example of a system context diagram. It's showing you the system we're building or describing or documenting or designing and things around it. But of course, as developers and architects, we want more detail. So how do we do that? We can drop down to level 2 and we can draw a container diagram. To draw a container diagram, it's a different set of questions because now we're looking at a different level of detail. So what are the major technology building blocks? What are the applications and the data stores that make up this system? What are their responsibilities and how do they communicate? Answer those questions and you can come up with a diagram like this. So you'll notice the red box is now a lot bigger. So now we're zoomed into the inside of that financial risk system red box, and we're showing the applications and the data stores that make up that system. So here we have a couple of Java Spring server-side things. There's a couple of React front-end web apps, some data stores, etc., etc. One thing I want you to notice, because we're going to talk about this later, if I go back a second, this is the context diagram. You'll notice there are 2 users and 5 software systems. When we zoom into the container diagram, we should hopefully see 2 users and 5 software systems. There's one missing here, but never mind. Which one's missing? The monitoring system as usual, probably. So we're repeating elements across our diagrams. And that's something that is going to be important to focus on later. C4 is notation dependent. A lot of people on the internet seem to think that C4 is blue and gray boxes. That's not the case. So you can use any shapes, any colors. That's entirely up to you. And you could also use UML if you want to. So C4 is just a set of abstractions and a set of diagram types. Whatever notation you want to use is entirely up to you, and that's all fine by me. So tooling. When it comes to tooling, I've tried to assemble a list of all of the tools that provide some degree of specific support for C4 on the c4model.com website. So click the link, it takes you down. Some of these are diagramming tools, some are modeling tools, some are commercial, some are open source, and there's a bunch of tick box filters that you can use to try and find some tools you might want to evaluate. Most teams generally use these types of tools. Who's using these types of tools for drawing diagrams, architecture diagrams? Yeah, this is going to be a big number of people. So this is your Visio, Lucidchart, Draw.io, Diagrams.net, Confluence, and Glyphy style tools. These are general purpose diagramming tools. You open a blank canvas, a blank document, and you start adding boxes and arrows. These are fantastic tools. They're very sophisticated tools, and I love them, but I do not recommend them for drawing software architecture diagrams, especially if you're going to use C4. Why am I saying this? Number one, a general purpose diagramming tool can't help you. So you open up a blank diagram and you're going to draw a system context diagram. So you add a couple of boxes and then you decide to add a component to your system context diagram. There are not many rules in C4, but one of the rules is don't have components on a system context diagram. A system context diagram should really only include people and software systems. So we've broken one of the rules of C4 here, and the diagramming tool can't tell you that you've done that because it doesn't know what you're doing. All it sees is boxes and arrows of different colors. So there's no rules, there's no guidance, there's no semantics. Number two, there's no consistency. The responsibility is on your shoulders to provide consistency across all of your diagrams. So you sketch up your context diagram on the left, and then you open up a new tab, a new diagram, a new canvas, and you start to sketch out your container diagram. And then you decide you want to rename something. So here you'll notice the names don't match. Remember when I showed you the example drawings? We repeated the users and the software systems. You have to do that with C4. Which one of these two names is correct? See, now we've got an inconsistency. We have to go back and make sure everything matches. This is fine if you only have 2 diagrams. If you now have 20 diagrams, this gets much more complicated much more quickly. We like using Git and source code control tools. We like putting these diagrams in source code control so we can have easy access to them and version control them and pull request them, etc., etc. If you try and dump out many of these diagramming tools to text-based formats, you often get a horrible big base64 encoded string or an XML file. These things tend to mix up the content and the presentation. So if you have an architecture diagram and you change the color of one box, you'll get a completely different file, which is kind of annoying. It makes your diff absolutely gigantic. If you can diff it, of course. So this mixing of content and presentation makes diffs really hard to do. You can't automate many of these tools. Imagine you have an AWS or an Azure environment. It's very hard to point some tooling at these environments to reverse engineer a diagram and create that automatically in a tool like Visio. There are ways to do it, but it's not particularly straightforward. These tools are very hard to integrate into CI/CD and build pipelines. And these tools are a pain in the ass. Right, this is my biggest problem with these tools. You spend far too long lining boxes up. You'll notice that arrow looks straight. It's not, it's 1 pixel out. And we've all been there and we've all done it. You have to start nudging elements around the canvas. And then you get the text in the top box, which just fits, but maybe we should make the text smaller. But now should we make the text smaller in all boxes or just that one box? Right, we shouldn't have to be dealing with these sorts of silly issues. So back in October 2020, that time that some of us would maybe rather forget, the ThoughtWorks Tech Radar blipped diagrams as code as a thing they recommend that you trial. Diagrams as code is basically, instead of using a UI to draw some pictures, you write some text, some DSL, some code, and the tooling creates diagrams for you. The most popular and frequently seen tools are PlantUML and Mermaid. Diagrams as code is great because as developers, we like text. We have tons of tooling to support text, IDEs, VS Code, etc., etc. It's easy to author. We can automate these things because many of these tools are command line driven. The text files are text, so they fit in source code control nicely. They're easy to diff. There's lots of good automation opportunities with these types of tools. There's something called C4 Plant UML. So Plant UML is a generic kind of UML-based tool for drawing UML-style diagrams. C4 Plant UML is essentially a set of macros that sits on top of Plant UML and allows you to describe C4 concepts using terms like person and software system. So it kind of elevates you into a much more C4 style domain-specific language. So that's quite nice. That's what a lot of people start with when they want to draw C4 diagrams with the diagrams as code tool. The problem with these tools is that they are still diagramming tools. If you want to create 2 diagrams, you have to create 2 text files. If you want to rename an element, you have to rename it in both text files. There are ways you can do include, so you can include a common set of elements in multiple text files. And as developers, we do have VS Code, and we can use global search or replace. So some of these problems are solvable, but fundamentally, if you want 2 diagrams, you have to create 2 text files. We're using Plant UML and Mermaid as an input format here. I want to change how we do this as an industry, and I want us to move away from diagramming and back to modeling. Now, when I say modeling, lots of old people in the room get scared because we've all seen this. You know, back in the early 2000s, late 90s, rational rows. Who's used rational rows here? Anybody? Yellow boxes with a purple or pink border. That looked absolutely horrible. So rational rows was a very big, very expensive, very bloated tool. We used to spend months and months and months plowing all of the information into these tools to get some wonderful looking diagrams, and then the project gets cancelled. There's lots of bad associations around modeling and modeling tools, and that's why many teams have thrown all of this modeling stuff away, and they've really gone back to drawing sketches on a whiteboard. That's led us to the problem we have today, where those sketches are completely incomprehensible. So I'm a big fan of modeling, but I don't necessarily want to take us back to rational rows. I want to do something a little bit different. So during the pandemic, so the way I earn most of my living is I fly around the world and teach people how to do software architecture diagrams. It turns out you can't do that when you're not allowed to leave your island that you live on. So I had not much to do, and I built some tooling called the Structurized DSL. Everything I'm going to show you is all open source. It's all available on GitHub. The Structurized DSL is an open source text-based domain-specific language that I designed specifically for crafting up C4 architecture diagrams. I like to call this diagrams as code 2. So if you want to create 2 diagrams, what you do is you create a single file and have the tooling spit out and create and automatically generate multiple diagrams. This is the concept of modeling. The concept of a model is fairly straightforward. You create yourself a single dictionary of all of your elements and relationships, and then you reuse them across your diagrams. If you want to rename an element, you rename it in your model, in your dictionary, have your tooling regenerate your pictures, and everything is now completely in sync. That's the power of a model. Why is this useful? Many people start out with C4 Plant UML. They create a bunch of text files in Plant UML format, and that works for small projects or small code bases. And then over time, they add more. They want to model more systems in their environment, in their group, in their department, and they start to get inconsistencies between all these different diagrams. And I've seen this. I've seen many teams move from tools like Plant UML and Mermaid to the Structurized DSL because it fixes the inconsistency problems, which means you can now start to do things like enterprise-wide modeling of all of your software systems, for example. So really, this is models as code, as opposed to diagrams as code. And I guess more accurately, this is really just focusing on C4 models as code. There's one concept I'm going to talk to you about before we dive into a tooling demo, and that's called a workspace. A workspace is nothing more than a wrapper for a model, which is a set of elements and relationships, a set of views. The views get rendered to diagrams, and some supplementary documentation if you want it. So, enough of the slides. Let's jump into a demo. I have Docker running here, and in addition to the Structurizer DSL, I built some tooling called Structurizer Lite. Structurizer Lite is a Java Spring Boot application, half server-side, half client-side in JavaScript, and essentially it's a rendering engine for these diagrams. So what I'm going to do, here's my desktop, which is currently empty. I'm going to start up Structurized Light. Let me show you the script first. This is just booting up a Docker image, doing a port map, and doing a volume mount. So I'm going to start up Structurized Light against a folder on my desktop which doesn't yet exist called NDC. So I'm going to start that up. Here you go, Structurized Light. This is available on Docker Hub. It's also available as a Spring Boot WAR file if you want to run it that way. So now Structurized Light is running. We can go to Chrome, go to localhost 8080, and we have a diagram. So where did this diagram come from? So what we have here on our desktop is now that NDC folder, and inside of the NDC folder is a file called workspace.dsl. This is the structurizer DSL. So here's our workspace, our model, and the set of views. We are defining a person with the name user and assigning that to an identifier called user. We're defining a software system with the name software system and assigning that to an identifier called software system, just to be confusing. And we're creating a link, a relationship between the user and the software system with a description of users. We're defining a system context view for the software system. That's just a diagram identifier. And we're saying include star. What include star does here is it says include that software system and include anything pointing to it or pointing from it. So this little bit of text gives us this diagram here. One thing you'll notice with many of the PlantUML Mermaid style tools is they are all automatic layout. Automatic layout, I think, works okay for small diagrams. I don't like it. I don't like automatic layout because when I'm drawing a software architecture diagram, I want to put boxes in a specific place. I want a nice flow from left to right or top to bottom. I want my web apps at the top and my databases at the bottom. And sometimes automatic layout doesn't necessarily do that in the way I want it to. So this Structurizer Light tooling by default is a manual layout tool. So what we can do now is we can start moving boxes around. We can change the canvas size. We can introduce line breaks. We can change the routing of things. This will save. We can go back to the DSL. We can now change the name of something. So let's call that business user. Save it, go back, refresh. And there's a merging algorithm built into this tooling that tries to figure out what you just changed and replaces it on the diagram accordingly. Now, some of you might be thinking, well, where are these box coordinates stored? Because it's not in the DSL file. And you're absolutely correct. There's a JSON file here. And the JSON file contains the full kind of breakdown of that workspace definition. So here we have our model and our people, and here's our business user, a bunch more stuff. Here's our software system, and here's the view with all of the XY coordinates. So what you can now do is you can take this folder, check these two files in source code control, and now anybody on your team can boot up this Structurizer Light Docker container with that folder and see exactly the same diagrams. So that's generally how I prefer to use this tooling. It's a manual layout-based tooling. For the purposes of the rest of this demo, I'm going to switch to automatic layout because it makes it a little bit quicker. You can do that by saying automatic layout, left, right, we'll go. So here we have an automatic layout version of that same diagram. So let's imagine now that we have crafted our context diagram, and we're happy with this, and we want to now draw a container diagram for this same software system. How do we do that? We go into here, we add a set of curly braces, and now we start defining the containers that sit inside that software system. We'll wait for that to go past. So let's define a web application, and that's going to be a C4 model container. We'll just call it web application. Let's define a database. We'll give that a name database. And let's say that the user has a link to the web application with a description of users, and the web app has a link to the database with a description of reads from and writes to. So if I save this and go back here and refresh, what's going to happen? Any ideas? Nothing. So I've added elements into my model, but I've not created a view to visualize those elements. So what we need to do is we need to create a C4 container diagram. How do we do that? What we do is copy paste this block. We change this, so we want a container view for the software system. We'll need to change this diagram identifier. Include start is now going to do something different. Include start is going to say include all of the containers inside that software system and everything linked to it. And we're going to apply automatic layout once again. So now if I save that, go back here, refresh, you'll notice there's a little magnifying glass here. Now we can double click and we drop down to level 2 and we see the container diagram for that software system. So we have the user using the web application, which is reading from and writing to the database. We can start to now add more description onto this diagram if we want to. So we can say description stores interesting data, and that will show up on the diagram there. And we can start to add technology choices and things like that as well. So we can say technology MySQL, and that has appeared just there as well. So something I want to point out with all of this, because we're really talking about the concept of modeling here. One of the concepts we always talk about in software development, in coding, is do not repeat yourself. Dry. But I've done exactly that. So I have a link user to the software system with a description of users, and pretty much the same relationship between the user and the web application. So I've had to repeat myself, and I don't want to do that, because I want to make this simpler for me to change the names of these descriptions in the future if I want to. How do I fix this problem? The answer is delete that one. So now in this text file, we are defining two relationships, user to the web app to the database. So if I save this, go back to my container diagram, refresh, these are the two arrows we've just defined in the text file. If I go back to my context diagram, this arrow is still here. So this is a feature of this tooling called implied relationships. Because there is a relationship between the user and the web application, and the web application sits inside the software system, there is an implicit or an implied link between the user and the software system itself. And the tooling kind of works it out and adds it for you. You can customize this. You can add your own strategies for doing this, your own algorithms, or you can disable it entirely. So there's a whole bunch of ways you can do this. Just as a point to note, the tooling that sits underneath this DSL is basically an open source Java library. And there are ways to go from the DSL into that open source Java library. So you have complete control over everything that sits underneath this as well. So that's a kind of quick demo on the concept of modeling, creating a context diagram, adding some containers, etc., etc. We need to make this diagram look pretty. Like a bunch of gray boxes is not exciting at all, and most people do not want to put diagrams like this in their documentation. So how do we change the color and styles of these things? If any of you have done front-end development, so you draft up a bunch of HTML elements and you add CSS tags and you apply styles via tags, CSS classes. This is the same type of thing. So I can enable tooltips here, and if I hover the mouse over, you'll see that this business user, this person element, has an element tag and a person tag. The software system has an element tag and a software system tag. And containers have an elements tag and a container tag. So there are a predefined set of tags that get associated with these elements. And what we want to do is we want to basically add styles for these tags to change the look and feel of these diagrams. We're essentially separating content from presentation. So what we can do now is we can go down here and we can add a styles block, and we can say add an element style for the element tag. The background is going to be, let's go orange. So this changes all of the elements to orange. So we've applied that style to the element tag, which kind of hits everything. If we only want to change the shape of the person, we can essentially do the same thing. We can create an element style for the person tag. Background orange, red I think is a color, and shape person. So now we've basically changed the color of all people. So if you have a nice kind of corporate color scheme, you can just write yourself a bunch of styles and have this applied to all of your diagrams super simply. Or you can disable it and override it, of course. So that we've got our context diagram. We can double click in here. I want to change this database shape to a cylinder. If I look at the tags, element and container, element and container. What I need to do is I need to add a tag for the database element and then add an element style for that database tag. So let's do that here. We go back to our database definition, tags, database, save, refresh, tooltips. So now we have a database tag sitting on that element. And now what we can do is we can go element style for the database tag, shape cylinder. So now we have a database shape. One of the things I said during the little presentation part is if you're going to use boxes and arrows, make sure you do so with structure in mind. So the C4 model gives you structure, but what about the self-describing notation part? I've got a bunch of orange boxes. Well, it turns out that this diagramming rendering engine generates you a diagram key automatically. So it looks at what the element tags are and the styles and kind of pulls all this information together and generates you a diagram key automatically. So this is another thing that this kind of tooling takes away from your hands, which is quite nice. What else can we do with this? We can add things like icons if we want to. So I have an icon here for Spring Boot. Let's copy that into this folder. Let's go to the web application and say tags Spring Boot. We can go down here, create an element style for the Spring Boot tag, icon, Spring boot.bot, boot.png. Now we have a rather horrible green logo on an orange background, so that might not look very nice, but that's also included in the diagram key now. So every time you apply that Spring Boot tag, you get that exact same styling. So that's the basics of the structurizer renderer. Something I want to point out is that this is one rendering tool. The structurizer DSL, this thing here, is rendering tool independent. So you can actually render this same diagram with many, many tools. So what I'm going to do here is I'm going to take out the icon. For a reason I'll explain in a second. I'm going to copy this file into my clipboard. I'm going to go to, so at structurizer.com/DSL there is a demo page I've set up. It has a text editor on the left-hand side and a diagram on the right-hand side. I'm going to paste in this example here, go render. So this is going to give us the same example we just had locally with Structurizer Lite. So this is a nice way to try the tooling out if you want to try it out without installing anything. So this is the Structurizer Lite renderer, essentially now hosted on the Structurizer cloud service. Also on GitHub is there's a Structurizer export library. This is a bunch of Java code that basically takes those view definitions from the DSL file and converts them to something like plant UML. And I've embedded those exporters, that export library, into this demo page on the website. So if we get rid of that. So here is the plant UML definition of the container diagram, which I can render in the browser. And there's the diagram key. So here you have an alternative visualization of that exact same diagram now using the plant UML tooling. And the context diagram will be similar. Something you'll notice is different tools look and feel different. So what I've done is I've tried to replicate the look and feel of the Structurizer rendering engine in some of these other diagrams as code tools. It gets close, but not always exactly the same. So there's an export to plant UML. There's an export to C4 plant UML. C4 plant UML comes with its own blue and gray styling. So that's what you'll get by default. But it is possible to override that. So if I go here, I can say properties C4 plant UML.tags true. Go render. And this should look orange now. Yeah. So this is now a C4 plant.yml export with those styles from the workspace. So when you're crafting up plant.yml and mermaid diagrams by hand, you're using plant.yml and mermaid as an input format. This tooling is using it as an output format. So that's one of the reasons this is rendering tool independent. There's an export for mermaid. So mermaid is picking up in popularity because it's now supported on GitHub. You can render these things natively in readme.md files, for example. So that's the container diagram. This is the context diagram. There's an export for the dot format for use with tools like Graphiz. And if you have dynamic diagrams, you can export those to web sequence diagrams format as well. So there's a bunch of stuff you can do here, and this is all open source, this is all Java. You can write your own exporters to export to other diagrams as code type formats if you want to. If you really want to, you could potentially export the DSL to something like Visio. Now, I'm not suggesting you do that, but it is something that you could do if you really wanted to. So that's a quick demo of the kind of basics of the structurizer rendering engine, crafting up a model, and exporting it to different formats. On that note, if you want to export these formats from something like a CI/CD build process, let me shut down Structurizer Lite. There's something called the Structurizer CLI, just like a command line interface tool for this, this stuff, which I have installed here. And you can say export. The workspace is user Simon, desktop NDC, workspace.dsl, format, plant.yml. So that will generate me a bunch of plant.yml files in that folder. So again, you can have people check this DSL file in, and then your CI/CD build process can generate you a bunch of plant.yml files, which you then stick in source code control or do whatever you want with. In terms of the DSL itself, once you start getting larger DSL files, you might think, how do I split this up? There's a way to include fragments, so you can draft up a bunch of components or containers in a separate file and include it into your main file. And there's also a workspace extension feature. So what you can do with the workspace extension feature is you can have a single workspace that defines all of your software systems, and then you can have every individual team extend that workspace and add their C4 model drill down diagrams for their specific system. If anyone here is using tools like Backstage, Spotify's Backstage tool, or like a service catalog, it's the same type of approach. You define your service catalog, your system catalog, and then you have individual workspaces extending that service catalog to fill in the implementation details. So something I see a lot of teams doing is they want an enterprise-wide view of their software systems, but they want teams to own the individual documentation for those software systems. So that use case is also supported by this tooling. There's also some other nice things you can do with this tooling. Let me boot up Structurizer Lite again. If I go back to this diagram, so you'll notice on this diagram, we've lost the Spring Boot icon. We'll bring that back in a second, but this container doesn't have any technology choices like MySQL does. So let's add a technology description here of Spring Boot. If I can type properly. So that's going to now add Spring Boot into my diagram. And if I bring back that element star for the Spring Boot tag, let's go background green. Again, duplication. So I've mentioned Spring Boot twice here, which is kind of annoying. It would be really nice if we could just set the technology to Spring Boot and have a tag kind of automatically associated with that technology choice. And that's something you can do. So what I'll do now is I'll delete that tag. So I'll go back here and refresh. So now we've lost the Spring Boot tag. We're just back to element and container. The DSL actually supports a bunch of scripting languages that are supported by the underlying JVM. If you want to go to the documentation for all of this stuff, you can go to docs.structurizer.com. Again, this is all open source as well. If you see any errors, please raise a pull request. If we go to the DSL, there's a cookbook. And the cookbook has a bunch of like recipes for doing common things. And one of those common things you can do is scripting. So scripting is supported with languages like Groovy, Kotlin, or JRuby. And I can write a short script that basically converts the technology to tags. So what I'll do, I'll copy that to my clipboard. I'll put this underneath here. So what the script is doing is it's getting the model from the workspace, looping through all of the elements. It's finding the elements that are an instance of the C4 model container, and it's basically saying add a tag with the value of the technology field. So now if we save that, oops, and go back here and refresh, we should go green again. There we go. So now this thing has a Spring Boot tag that we've only defined once in the technology property of that element. So there's a whole bunch of stuff you can do once you get under the covers of the DSL to the underlying Java library. You can add, remove relationships and do all sorts of fancy stuff. So that's, again, basic example. Let's shut down Structurizr Lite. If you go to the c4model.com website, you'll notice there are a bunch of example diagrams for an internet banking system. I don't want that one, I want this one. So I'm going to boot up Structurizr Lite against that set of diagrams, that workspace. Open up the tab. Yep. So here are the example diagrams. So we have our system landscape diagram. Double click, get to the system context diagram. Double click, get to the container diagram. These are the same examples you'll see on c4model.com. Double click, get to a component diagram. Double click, we have an image of a class diagram here. So level 4, the code level, is not supported natively by the Structurizr DSL tooling, but you can add in an image file or a plant UML definition or a mermaid definition. We also have a dynamic diagram here. So this is interactive. It's showing you how the sign-in feature works in this particular example. You can export this to web sequence diagrams if you want to. And things like deployments diagrams are also supported. So this is showing a deployment environment, and this is showing a live deployment environment. So those are the diagrams rendered in the Structurizr Lite tooling. The reason I've shown you this is because there's another tool called the Structurizr Site Generator, which is, again, open source, nothing to do with me. But it takes that same workspace definition. It's in this case, it's just another Docker image I'm booting up. And it gives you an alternative way to visualize the data that's stored in that workspace. So this is the Structurizr Site Generator. We can go software systems. We can click on internet banking system. And what it's doing is it basically built us a little static website here, which gives us a view onto that model. And we can start clicking around. So here's a context view for the internet banking system. This is using the plant UML exporters, in this case, the C4 plant UML exporters. And what the people behind this tool have done is they've hyperlinked the diagrams together. So you have here a set of hierarchical but navigatable diagrams based upon plant UML in your web browser. And it shows you deployment views, and you can click dependencies and start kind of hunting around the model to kind of see different relationships and what's going on. So that's another interesting tool. It's another interesting way to visualize essentially the same information. So that's Structurizr Site Generator. You'll find a link to that from the Structurizr documentation. One of the big questions I always get with all this tooling is, well, hang on a second. All of your example diagrams have been like 4, 5, 6, 7, 8 boxes, and they all look quite neat. How do we make this work for bigger systems? So what I'm going to do now is I'm going to boot up Structurizr Lite against a kind of service, a microservice-based example. So imagine we have some sort of a service-based architecture. So we have a web application that has a connection to service 1, where service 1 in this case is an API talking to some sort of a database schema. And then maybe that has a link to this thing over here, which is service 2, some sort of API and a database. So we have some sort of a service-based architecture. And every service is an API and an individual owned data store. And I've associated different colors with every different service. This example looks okay. We've only got like 16, 17 boxes on here, but as you add new services, this diagram would start to get much more complicated, wouldn't it? So how do we fix that problem? This diagram is showing you all of the services. It's one diagram showing you all of the services. What you can do instead is draw one diagram per service. So here we have a container diagram that's just focused on the service 1 thing, things coming into service 1 and things leaving service 1. Here's service 2, same thing, inbound relationships, outbound relationships, and here's service 3. So we have different views of essentially the same data, the same model here. How do we do that? We go to here, I can show you the source code for this thing, services. So this is the same thing, we're creating a workspace with a model. Here's our software system. This is the definition of service 1. So service 1 is a group of an API container and a database container. Service 2 is the same thing, service 3 is the same thing, etc., etc. Bunch of arrows between them. Someone's stuck in traffic. This is the all containers version. So this is saying include all containers for that software system. This is the service 1 version. So what we're saying here is include software system.service1, include things coming into that thing and things coming out of that thing. So the inbound and outbound relationships, the afferent and efferent couplings, if you want to use that terminology, and apply automatic layout. Same with service 2, same with service 3. So this is a way to basically give you a bunch of different views onto that same underlying model, which is really nice because, of course, in tools like Visio, what you do is you craft up your big diagram, and then you have to start copy-pasting elements across multiple different worksheets and things. And you start to get that inconsistency problem. So this is another approach. There's a bunch of expressions that are built into the structurizr tooling that allow you to slice and dice your model in various different ways. So I've mostly been using include star, but you can include things by name, include things by reference, include things by tag. You can use this sort of expression which says include the thing and inbound relationships, etc., etc. So there's a whole kind of complicated expression language that's built into this tooling as well. So that's option 1. I like giving people options. This is option 1 for dealing with large and complicated software systems. We have a diagram with everything, and we have multiple diagrams showing one service. Option 2 is Instructorizer Lite, which is all free, it's all open source. You click this Explore button, and you get this. So this is a D3JS force-directed graph. It's showing you exactly the same information. This is showing you all of the containers inside that software system and the links between them, but it's showing you in a much more succinct, concise data, in a much more concise visualization format. It's interactive, there are tooltips, we can hover over relationships and things, we can start clicking things to show nearest neighbors, and there's a quick find feature. So this is another really nice way to kind of explore and visualize larger models. Especially useful for portfolios of systems across an enterprise, or maybe if you have a complicated distributed architecture, or maybe have a large number of components inside a monolithic application. This type of visualization suits larger data sets. So that's option 2. I'm going to give you another option. There is another export format, let me shut this one down, that the Structurizr CLI supports, and it's called Ilograph or Ilograph. So I'm going to export the workspace we just looked at, and the format's going to be Ilograph. That's going to create me, what have I done? I know what I've done. That's going to create me this file, a .idl file. So this is the Ilograph format, which is YAML. I don't know how you feel about YAML. I'm not a big fan, so I wouldn't necessarily recommend crafting this by hand. But what I'm going to do is I'm going to copy this into my clipboard. I'm going to go here and open up app.ilograph.com, which is this one. I'm going to click New Diagram. I'm going to take out their example, paste mine in, minimize. See, it's horrible, isn't it? We'll get rid of that. We'll get rid of that. And we'll click Static Structure. So this is another alternative visualization of that exact same data. We have our web application calling services and database, etc. And you'll see as I move the mouse around, things hover. And we can also click and zoom. So it's a nice interactive visualization. So this is another great tool for exploring kind of larger data sets, hierarchical data sets, and of course the C4 model is essentially a force-directed graph of hierarchical elements and the relationships between them. So that's something else that you can do here. And that's really all I wanted to show you with regards to the structurized tooling. Is there's tons more stuff you can do. It supports documentation and architecture decision records, and there's an on-premises version which is free and open source, and you can embed in Confluence and tons of stuff like that. But that's kind of the basics of the structurized DSL tooling and some of the different rendering engines and possibilities. Just to finish up a couple of slides. The concept we've been looking at here is the workspace. The workspace is the wrapper for the models and views. There's actually a number of ways you can author those workspaces. I've shown you the structurizer DSL. There are also a bunch of code-based libraries. There's a structurizer for Java, there's a structurizer for .NET that allow you to craft up some code and basically get to that same workspace format. And then you can render those workspaces with a number of tools as I've been showing you throughout the demos. So that's my structurizer tooling and the kind of ecosystem around the structurizer tooling. And again, everything I've shown you is all completely free, completely open source. To make this a balanced discussion, I do want to throw out some other options out there, because over the past couple of years specifically, some people on GitHub have been creating similar types of tooling that gives you similar types of capabilities. So there's something called Overarch, which allows you to do the same type of thing. It allows you to define a hierarchical C4 model and get a bunch of views off that model. But this is using something called the extensible or extensive data notation, EDN. So this is a slightly different way to craft up those diagrams. I think this tool uses PlantUML as a rendering engine, so automatic layout only, but that's another tool you might want to look at. There's something called RDB modeling, which is a YAML file and an editor. So you kind of type in some YAML on one side and you get a diagram on the other side, and again, allows you to create a model and surface different views of that same model. So that's something you can look at too. If you like PlantUML, somebody has tried to create a way to build a model-based approach to using PlantUML. It's a bit complicated. I'm not sure I really understand what they're doing with the underlying kind of tech here. But if you're into PlantUML now, and specifically C4 PlantUML, this allows you to start exposing some of those things as elements you can reuse in other definitions. So that might be something to look at. Somebody created something called Like C4 recently, which I thought was quite funny. What they've done is they've taken my structurizer DSL and kind of copied it. But the big difference between Like C4 and my structurizer tooling is that in Like C4, you can have any number of hierarchical abstractions. So in C4, there are 4: software systems, containers, components, and code. One of the criticisms I hear of C4 is we don't want to be pigeonholed into only those 4 levels of abstraction. It would be nice if we could define more levels of abstraction, like a group or a service or a library or a module, something like that. There are a number of reasons I don't recommend doing that. I have another talk you can find online. It's called The Myths of the C4 Model. If you do want to do that, Like C4 allows you to define additional levels of hierarchical abstraction. So it kind of takes the structurized DSL and removes some of the restrictions around the levels of hierarchy. So again, something to look at if you're interested. Illograph, I've talked about already. The input format for this tool is a rather long YAML syntax. If you do use this tool, the editor thing does do autocomplete, so that does help you to some degree. But again, I built an exporter that takes the structurizer DSL and converts it to that YAML format, so maybe that's a better approach. And that's it. So I hope you found that useful. If you do want to get started, just go to structurize.com/DSL, you get that demo page, and this is a nice lightweight way to get started without installing any tooling. Thank you very much, and enjoy your lunch.
Test, test. All right. Looks like we got our audio. Hello, everyone. Good afternoon. Welcome to the last day. You made it this far and you're still attending sessions. That means you must still have some energy left to learn, which is great. I hope something useful will come out of this session for you. And I know we all just ate lunch, so you might be a little sleepy after this, so I'll try and keep it really interesting. Today we're going to talk about how to build a how to not build a distributed monolith, or in other words, how to avoid doing microservices completely wrong. I want to start out by telling you a little bit of a story. I'm a consultant. I am one of the owners of a consulting company called Trailhead, and we help our clients build custom software applications. And very frequently we'll have clients come to us like we did recently that have built what they call a microservices application. And oftentimes they'll come to us kind of right at the end of the project, just before it's supposed to launch, and they'll say something like this client told us, which is, we have a little bit of a performance issue with just a couple of the endpoints that we'd like you to get your help to fix before we go live. So with this client that came to us recently, that was also the case. And we started looking at their code and started looking at the architecture of the system that they had built, and it didn't take us very long to realize that what they had built was not at all microservices. What they had built was actually a distributed monolith. Now, if you're not familiar with this term already, I hope you are by the end of the talk today. This is the bad guy. This is the villain in our story today, the distributed monolith. That's why I put it in this scary font. Are you all scared? This is far from the only time this has happened. This has happened so many times with clients coming and saying, we built this microservice, it's not working well. And then we look at it and say, oh, this isn't microservices at all, this is a mess. And it happened so many times that I started thinking, I need to start collecting and sharing this information with the world. So that's what I'm doing here. This is the talk that I created based on that inspiration. I'm going to talk about a bunch of things today, but the main thing we're going to talk about is I'm going to share with you the 10 most common mistakes that I see our clients making when they try to build microservices and end up building something much worse called a distributed monolith. Hopefully this will help you avoid making these same mistakes. A little bit about me before I get started. My name is Jonathan Tower. I go by Jay for short. As I mentioned, I'm a founding partner and principal consultant at Trailhead. We do custom application development consulting. You can contact me at all these places online if you're interested in getting connected afterwards. I've also got this GitHub link here, which will take you to these slides if you're interested in looking at these again later. I'll also post these on the Slack channel if you're on that. I'm also a Microsoft MVP 9 years in a row for .NET. Started out in ASP.NET, and then that got merged, and now I'm on .NET. And one other thing I just want to mention on this slide, I'll show this slide again at the end if you want to get any of this information again. But something special I like to offer to anyone that comes to one of my talks is a free consultation. I know we'll have some time for Q&A hopefully afterwards here. If you want to come up and talk to me afterwards, you're welcome to do that too. Sometimes maybe we're a little too embarrassed about the problems that we're having with our software, and we're not, don't feel free to do that in public, or maybe there's something proprietary or some context that you need to give me first. If you want to do a free 30-minute session with me and we can talk through what you're facing, I'd be happy to do that. You can go to this bit.ly link or this QR code and sign up for free. All right, so before we get started with the 10 most common mistakes that I see, let's make sure we're talking about the same thing with some definitions. So let's start with the definition of a monolith. Monolith is a traditional architecture of software development. If you've been doing this for very long, you've probably built many monolith applications before. It's easy to get confused nowadays. There's so many talks, even at conferences as good as NDC, there'll be a lot of talks about microservices, and it's this buzzword, and you start to get the impression that everything should be a microservice and nothing should be a monolith. And hopefully, the one thing I really want to convince you of today in this talk is that that is not the case, that monoliths can be good too. In fact, we've been building scalable monoliths for decades now, before microservices was ever an option. They're actually much easier to build than microservices are. They're actually also better at something called data latency, which is basically how long it takes from when you enter the data to when it's available, stored and available for the whole application to use. So there's a lot of pluses to a monolith. There are disadvantages as well. One of them is that if you want to make a change to a monolith, even if you're changing something small like the name of a button or the word that shows on a button, that requires you to change the whole application, right? We've all had this before where maybe there's a misspelling in one of our applications and you need to update it. Well, you have to rebuild the entire application and it has to go through your release pipeline and you have to update the entire application just to change that one button. So that's kind of a downside to the monolith. That does also mean that there's more tight coupling between the components of a monolith, which means it's possible to write some code that brings down the entire thing, right? If you have a class that's used in every single part of your application, you can imagine like a logger or something like that. You can imagine that if you put some bad code in there, that would bring down your entire application. And then finally, one of the disadvantages is that you have to use the same technology stack. When you're doing a monolith, you have to build the entire thing using the same stack of technology because the whole thing is built and deployed together. You also, this really works best if you have a small team that is all working on the same thing. And it doesn't work as well if you're trying to have a huge team with lots of different people focused in just specific areas, working in just their specific areas of expertise. What's a typical monolith is going to look something like this. It's going to have clients that are connecting to a middle tier part of the application, and then some sort of a data store like a relational database or a NoSQL database. This is your typical application architecture. One of the common reasons that I get that people say that they're using the microservices architecture is because they want their application to be scalable. Now, that is true that microservices are more scalable in some ways than monoliths, but monoliths are scalable too, and you probably all know this. I'm probably repeating information that you know already, but you can scale up a monolithic application by adding more processor cores, more memory. You can also scale up the database portion the same way, right? You can make a more beefy server or virtual server to run your application, and you can scale it up that way. You can also scale horizontally when you're doing a monolith. This is most commonly done with things like load balancing on the middle tier, or if you're talking about on the back end storage, you're going to use something like data sharding, where you're splitting your data up and storing it into different data stores depending based on one key or other, like your user ID or your customer ID or something like that, that is a good key to kind of split your data up based off of. So there's lots of ways to scale a monolithic application. And I want to underscore that just because I hear that reason so much, and it ends up oftentimes, as I talk more to those people, I'll find out that it's the only reason that they built microservices, and it turns out it's actually not a good fit for their needs. There's actually a couple different kinds of monoliths. Hopefully you've been hearing me say this already, that monoliths aren't always bad. So there is something that I call a modular monolith. This is hopefully the type of application you've had the chance to work on before, where you can go into the code, you can change things really easily. You don't have to change things in 5 places to make one simple change. Changing something in one place doesn't break something in another place, right? It's basically a well-designed, modularly created, low coupling monolith. It's still a monolith if you have to compile the whole thing together and the whole thing goes through one DevOps pipeline to be released. It's still a monolith if you have to release the entire application just to update one part of it. But it could be a really well-designed monolith, and therefore it would be a modular monolith. Now there's another kind of monolith, which is I think the one that we all think of when we hear that word monolith, which I call the ball of mud monolith. You know you've worked on one of these before if you go into the code to try and make a change over here, and then you find out from QA or from your users that you broke 5 things over here. If you know that you're working on a ball of mud monolith, if every time you make a change, you break things that you don't realize you're breaking, and your customers, your end users are mad at you all the time because there's always seems like you're making the system worse instead of better, It's probably because it's a poorly designed monolith. Now that doesn't mean that microservices is a bad fit for you. If you're on a ball of mud monolith, you might be a better fit for that project to go to a modular monolith architecture, and it might be a better fit to go to microservices. By the end of this talk, I hope you will have an easier time identifying those situations. Next definition I want to cover is microservices themselves. Now, I think there's a very interesting definition of this that Google uses internally for their teams. They refer to the definition of microservices as both the architecture and organizational approach to software development. Notice that. It's both an architecture and an organizational approach. Why do I want to underscore that? Because I bet all of us, before I said that, think of microservices primarily as an architectural approach, right? But it's very important, I think, to realize that not only is it an architectural approach, but it also requires you to reorganize your team, your processes, to actually fit microservices. The rest of the definition Google uses internally is it's a kind of software approach and team organization that leads to software composed of small, loosely coupled services that communicate with each other through well-defined messages and are owned by small, self-contained teams. So that's back to that organizational structure that I mentioned, right? Small, self-contained teams. There's a lot of benefits to microservices. If you have a well-designed microservice and part of your application gets a lot more traffic than another part of your application, you can scale up just that one part of your application. So that's more like targeted scalability or precision scalability. It's also possible to take part of your application down for maintenance while another part stays up and completely operational. Imagine you have part of your application that's taking orders. Maybe you do millions of orders an hour and you don't want to lose money by taking that down for maintenance, but you have other parts of the application that need to be updated more frequently, maybe like user profiles needs to be updated occasionally. Well, you don't want to take down your ability to take orders in the middle of the day just so you can update the user profile part of your application. So microservices are really great at that. Of course, I mentioned before different technology stacks. That's possible in microservices. I don't see a lot of teams doing this, but you could imagine that maybe part of your team is more familiar with Java. That's okay, you can be friends with them anyway, right? Maybe part of your team's more into .NET. Those are obviously the cool people on your team. Maybe someone is into something cool like Rust or Go. But you could have different parts of your organization that has different expertises, and they could build their part of the application in whatever technology stack is the best fit for their part of the business. And then also I mentioned the team organization. So if you're doing microservices, it makes a lot of sense to have separate teams who are each focused on different microservices, and they become experts in that part of the business. And really, there's very little need for them to cross over into other parts of the business. So then the villain of our story, the distributed monolith. What is a distributed monolith? Well, nobody sets out, hopefully, to build a distributed monolith, but when you get a distributed monolith, usually it's because you set out to build microservices, but you created them in a way that were tightly coupled. And when you deployed a tightly coupled application in a distributed way, it became much worse than if it was just a monolith, or obviously if it was a pure microservices. This is what a typical distributed monolith is going to look like. I'm sorry, this is what a typical microservice architecture is going to look like. A typical distributed monolith architecture is going to look just the same, except because you're setting out to build microservices, but it's going to fail in the sense that all of the services are going to be talking to each other. Maybe they're going to be accessing each other's databases. Maybe they're going to be sending synchronous HTTP REST calls to each other. All of these types of things create coupling between these applications, and we're going to talk about a lot of examples of this as we're going into detail. Now, I specifically left the event bus off of this slide, but I want to show you that most people who set out to do microservices will include an event bus because they will have read on a blog or something that you're supposed to have some sort of an event bus or a queue. And so they will include it, but then because they're sort of used to building a monolith, they know how to have one module call another module, and so they'll write their code the way that you would write a monolith, and they'll just have one service calling another. Maybe the most popular way I've ever seen a microservice built is this one. I love to show this slide because once I get to this point, most people are tracking with me, and I get so many smiles when I put this slide up because I think people come up to me afterwards and say, this is what my company is building right now. It's microservices, but the DBA, when we told him we were building microservice, he said, over my dead body, right? And I can give DBAs a little bit of credit for that because they've been trained their entire careers and their entire education not to repeat data, right? Normalize data, don't have multiple copies of data, don't try and synchronize data all the time. Try and get it all into one place, put it into nice normalized tables with perfect relationships between each other, and they're trying to protect that, right? So you come to them and say, hey, we're gonna do microservices, and they say, well, in that middle tier, you can do whatever kind of crazy architecture you want, but you're not touching my database, right? So this is what I see frequently at companies, and they end up saying, look, what we'll do is you can just put everything in the database, and I'll set it up the way that I normally would, and all these different applications can call it, and that'll be microservices. Well, we're going to look at today how this creates a lot of coupling between these applications that makes them a distributed monolith. So if you organize these a little bit on a graph, the ball of mud monolith is monolithic physically. It's deployed as a single piece, but it's also logically monolithic. Everything is tied together so tight, you can't really separate things, you can't update things easily. The modular monolith, which is a perfectly great architecture, it's more modular in the way that it's logically organized, but it's deployed as a single piece, so it's still physically monolithic. The distributed monolith is what you get when you try to create microservices, but you end up creating them in a logically monolithic way with all the code referencing all the other services. And so you end up with it being physically distributed, but still logically it's monolithic. And then you end up with true microservices up there in the corner where you've got it both physically distributed and logically modular. So now that we're all on the same page, hopefully, about those terms, let's jump into these 10 most common mistakes that I've seen companies make over and over again. The first one, maybe this one won't surprise you at this point in this talk, but number one is assuming that microservices are always best. There's some great books out there about microservices. Maybe you've read some of them. Sam Newman from the UK has created one that's really excellent. He says in that book that if you're going to do microservices, you should have a really good reason, is what he says. Now he goes into more detail to describe some of the reasons that he thinks are valuable reasons, but I've kind of outlined a few of the downsides here. If you're trying to do microservices just because you're looking for something that is scalable, while monoliths can be scalable, we talked about that already, microservices are really hard to do. Based on my unscientific survey of our clients who've come to us looking for help, I would say over 90% of microservice projects are actually some kind of a distributed monolith. Nowadays, it's such a buzzword, but nobody's really been doing microservices for 10 years or anything like that. So probably there's nobody on your team who says, oh, I've built dozens of successful microservices. I know exactly what to do. So you're trying to figure it out. And when you try and figure it out, you very likely, if you haven't been to my talk, will make some of these 10 mistakes, and it's very easy to end up in the wrong place. And then finally, the wrong reasons to create a distributed monolith. So what are some good reasons? I talked a little bit about independent scalability, so scaling different parts of the application. Talked a little bit about independent deployability, if you have to be able to take parts of the application down frequently while you're leaving other parts up. I attended a DevOps talk a while back with an Amazon engineer. He was talking about, at the time, for Amazon.com, the e-commerce site, they were doing tens of thousands of updates to the website every day. Tens of thousands of releases happening in a day. Now, if you had a monolith, basically your application would be down all day, right? Like a lot of my builds take 4 or 5 minutes, and then it takes another minute or two to do the release. You couldn't even do 10,000 in a day if it takes that long. Your application would be down all day long, right? they need to, at Amazon, they need to be able to do independent deployability. They need to be able to update parts of the application without taking any of the rest of it down, because they would lose millions in 50 seconds if they were down, right? Isolating the surface area of failure. If you have part of your application that takes orders, or it's where the money comes from for your business, you probably want to make sure that that is as isolated as possible from all the other systems. You might want to have queues, event-driven development going on behind the scenes so that it can take orders even if all the other systems are down for a whole day and just queue them up. So that's something that you can do much easier with microservices. And then I mentioned it a couple of times, but independent teams. If you have 60 developers or 100 developers and they're all working on a very large application, but they're all kind of focused in different areas of that application, well, then it makes a lot of sense for that team to work on a microservice. There's a big trade-off with microservices, which if you only remember one thing from this talk, I want it to be the last thing, which is that microservices aren't always the right thing for every project. If you only remember two, have it be this one. Microservices are inherently bad at immediate consistency. They have something called eventual consistency. They're very good, if they're designed well, at something called high availability. So microservices, someone can trip over the power cord in the server room and bring down one of the microservices, and all of the other ones are still fine. Someone can write some bad code and deploy it to one of the microservices. All of the other microservices will still run. But because of that distributed nature of a microservices architecture, all of the different applications are going to get data updated to them eventually. That's that eventual consistency. Monoliths usually will have a single data store, or at least a single data store per like data shard. And because of that, they'll have immediate consistency. As soon as you finish the database transaction of writing, then everything in the application is aware of that new data that's been written to the database. They can now read those updates, right? So if you want high availability, microservices might be the right architecture for you. If you want immediate consistency, then monoliths might be the right architecture for you. I mentioned this when I was showing you what the typical architecture looks like for a distributed monolith, but very commonly I see the data store, the database being shared between the different microservices. Another one that you might have not thought of, though, is the data models themselves, the models that represent that those data stores. So imagine you have this scenario where you're building what you intend to be microservices. You have all these different services, but they're sharing a database. And service one over here has a team that says, we need to make a breaking change to this table in the database, but it's our table. It belongs to our microservice. So we should be able to make breaking changes to it because we can update the code and we can deploy those changes all together. So they go ahead and break something in the schema of this database. Now, even if you set out to not share databases, as soon as share tables, even as soon as you have the same database, I guarantee it'll happen. I've seen so many projects start out where they said, well, we'll each have our own schema in the database, and we'll have different logins with different security. And what ends up happening is somebody gets lazy and says, I really need that table, and I don't want to wait for an event to publish the information from one service to another. I'm like already connected to this database. I'm just going to do a real quick select statement and get that information right from the database. It'll definitely happen if you allow everybody to connect to the same database. So what happens when team 1 breaks the schema? Well, team 5 over here didn't know about it, and maybe team 1 didn't know that team 5 was cheating and looking at the schema of a table that belonged to team 1. So now microservice 5 just broke. So is this high availability? Is this independent applications? No, right? It's very easy when you're sharing a database to accidentally break things. So what do we want it to look like? We want it to look like this. Every application has its own database. If they need to share information, they should do that through asynchronous method like an event bus. This is the quote unquote right way to do microservices that will not create coupling between these different microservices. Let's look at an example of data models as well. So imagine you're writing all of your code in C# for all of these microservices, and You're used to doing monoliths, so a lot of your applications, you'll have these like massive Visual Studio solutions with 20, 50 projects in them, right? And you're used to doing things that way, so when you start creating microservices, you do the same. You create a class library, and it has all of your data models in it, and everyone can access that. That's kind of how you would normally do it in a monolith. Well, in microservices, that should probably be actually separate libraries, one for each. And I know that also, sort of like the DBA I was talking about earlier, that sounds like it's breaking all the rules that you've learned over the years about how to design good architecture, right? Everyone's learned dry, don't repeat yourself in good coding. And if you're doing microservices correctly, you probably do need to repeat yourself. So imagine this scenario. I just stayed in a hotel since I'm visiting from the US. Imagine that the hotel I stayed in has microservices for all their different parts of their business. They want to be able to take reservations all the time because they want to, they don't want that part to go down. So maybe it's a good fit for microservices for them to use this. And they've got maintenance and housekeeping and maybe some other microservices in there. They've got, obviously, a hotel room object is going to be a really important one in their data model. So right now, all of those services are sharing that same model for their hotel room data. It's got information in it like, is it occupied currently? It's got how many beds are in there. It's got how long it takes to clean. Maybe it has like a related entity that's like a child entity that's like the repair history in that room, or maintenance requests or something like that. So now what happens if the housekeeping service says, you know, we don't really care how many seconds it takes to clean a room, we care how many minutes. So we're going to go ahead and update that from a float to an int. Be a little bit less accurate, but it's plenty enough accuracy for us to know how long to plan for every room to be cleaned. So they make that change. Well, if everyone's sharing the same data model, before they do an update to their system, everyone else is going to have to do an update to their system because now they have the wrong type that's not going to match. The model is not going to match their data stores because maybe all these other microservices are still using a float for that minutes to clean property. So because of this, what you actually want to do is you want to split these data models up. Ideally, you would put the data in only the place that it's needed and then copy it to all the other places through events if other places need that information as well. So in this example, I have the hotel room under reservations, whether it's occupied, and the number of beds. I have a different hotel room under maintenance that just has the repair history, and I have a different hotel room under housekeeping with just the minutes to clean. So you might already be asking, like, well, what about those examples, Jay, where there's data that all of these applications need? So here's an example. Let's say you have an admin service that's like your back-end administrative interface where people can do things like creating new hotel rooms. Maybe there's been an expansion to the hotel, and there's now some new rooms that you want to add to your hotel. So you go into your admin module, and you hit the service that adds a new hotel room. It stores it in the admin module. The admin module then will create an event. Let's say it's like a hotel room created event that it will publish onto the queue or bus. And then anybody that has subscribed to that event will get that event. And depending on what technology you use down here for your event bus, you can make it so that even if these other services are down for maintenance, that they will get this, when they come back online, they will get these events. You can, make guaranteed delivery. So all of these subscribers will get this information, and they can now update their own copies of this data to say, I now know about hotel room 124. The last I knew, the hotel rooms only went up to 123, and now I know about hotel room 124. I'll go ahead and create a record for those in my part of the system as well. So that's kind of how you would do it with the event bus and without sharing your data models. Mistake number 3 is microservices that are too big. Hopefully many of you are already familiar with DDD, or domain-driven design and development. If you are not, this is a great book that you can use to get started learning about it. It's a large and fairly complicated topic, so we don't really have time to talk about it in a lot of detail today. But I do want to mention that if you're trying to figure out where do I draw the lines between different microservices and what goes in this one, what goes in that one, what you really want to use is this concept of bounded contexts, which comes from domain-driven design. It's pretty tricky, and it takes some time to get used to. So I recommend starting with this. There's also some other great books about it that I'm sure you'll be recommended on Amazon as soon as you add this to your cart. I have a simple rule, since we don't have time to get into 2 hours of domain-driven design and development stuff right now. My simple rule is that you're trying to create the smallest possible microservice without creating chatty communication between your services. Now, I'll give you an example of this after my next problem, which maybe predictably is microservices that are too small. So let's imagine an example where you have been to a conference, they talked about microservices, you said, I'm going to microservice everything. From now on, I'm microservicing all the things. And what's more micro than a single endpoint per service, right? I'm not going to make all these mistakes that Jay was talking about. I'm going to make the microest service I can. So I'm going to even have my user login endpoint be one service and my password reset be a different service. Doesn't get more micro than that, right? Well, what is the problem with this? Every time someone logs into that system, they might fail, and you want to maybe keep a count of how many times they failed. If they fail 5 times in 10 minutes, maybe you want to force them to password reset. Well, that means that every time someone logs in and fails, that information has to be synchronized between these two systems. It also means that they might fail really fast, and it might take a couple minutes for that information to get over to the other system. So they might be locked out of their account and then have to wait to reset their password until that system finds out about it. So basically, you're creating this kind of chattiness between these two services. Or even if you're using an event bus, there's a lot of events going into that event bus and a lot of subscribers to those events. Basically, anytime something happens in one, the other one cares about it. Anytime it happens in this one, that one cares about it too. So that's too chatty. I think that's clearly too chatty. So somewhere right in the middle is kind of what you're aiming for the right place to break up your microservices. If you have too much inter-service communication, you're going to have a very slow application with a lot of data latency. And if you have your service size too big, well, then you really don't have microservices. Eventually, if they get big enough, they just become a monolith again, right? So somewhere in the middle is kind of where you want to set that line. The fifth problem that I see is a lot of people starting a greenfield project as microservices. Why is that a problem? Well, greenfield microservices is actually harder than brownfield microservices. If you're not familiar with those terms, greenfield basically means starting from scratch or starting a new project, and brownfield is migrating something existing. The reason why it's harder is 4 things. Number one, if you have existing code, even if it's a monolith, even if it's a bad monolith, you have all of the relationships already documented on how the different parts of the application works. You could even do maybe an object diagram or a database diagram and see very clear places where you could actually break your microservices apart. If you've ever done a database relationship diagram, you've seen all those relationship arrows between all the database tables. You know that there'll be like a little clump of tables that have lots of interaction with each other, and then there'll be like maybe one line that'll go up to this group over here, right? That one line is kind of your indication that, oh, this might be a good place to break these microservices up. If there's an existing system, there's also someone to talk to, hopefully, if they haven't left the company from having to maintain a ball of mud monolith. There's someone to talk to that knows how the system works. Also, the system already works. Maybe it doesn't work great, but what's the number one thing that stops us from doing a good job with software engineering? Time, right? There's always deadlines. Has anyone ever had a project where their boss said, you can get this done whenever you want? No. So What's really great about having a system that already works, even if it's not great, maybe it's slow, maybe it's not ideal in some ways, but it works. It buys you time to do microservices carefully so that you don't make some of these mistakes that we're talking about. And then the last one, I think, is a really important one. It's the ability to have a baseline to compare to. You're trying to migrate to microservices theoretically because you're trying to make a better system than the system that you had before. And if you're trying to migrate to microservices, wouldn't it be nice to have a system that you could actually measure against to say, are we making something better or are we actually making something worse? And that's something that you have when you're doing a brownfield migration. There's a bunch of different approaches to brownfield migration. If you've been in any of the other talks about microservices, I know they've mentioned some of these. The Strangler fig pattern is often put forward as the best one, which I would agree with. It actually comes from this really crazy plant that's in, I think, Australia, that starts growing in the tops of trees and it shoots these vines down the trees. When the vines get to the ground, they'll go into the ground and they'll wrap around the tree's roots. And they'll actually choke that tree off so it doesn't get the water or nutrients that it needs from the ground anymore. Eventually that tree dies and it just is like a backbone for the vine so that it can get access to the sun, which is up high. So it's kind of a violent, slow motion violent example, but it's actually a really good analogy for how you can do a migration gradually from a legacy application to a modern application. If you create a facade layer, you could imagine this being like an API gateway or something. You can start with a very small modern application and a very large legacy application. Maybe it's 100% legacy and 0% modern. And you can gradually move endpoints from one to the other, rewrite them in the modern application. All that time you're updating your facade, maybe your API gateway, so that the client applications are never aware of any of these changes. It all looks exactly the same to them, and everything continues to work the way it did before. But eventually, you finish migrating, and this buys you the time to basically put your application out with updates to it right away without having to finish the whole thing and wait 3 years while you're migrating it to microservices. Problem number 6 is creating coupling through cross-cutting concerns. Some of the common cross-cutting concerns that microservices have are all of the security or authorization and authentication related things. Logging is a common one. If you're going to debug a microservices application where a user interacts with this microservice, which updates its database and publishes an event to a bus, and then 3 things subscribe to that event and they update something in their database, you can imagine if something goes wrong, it's going to be really hard to figure out if you don't have really good logging. It's going to be hard to figure out what happened. So logging is very important, but it's also very difficult to do it in a way that doesn't create coupling between those microservices. And then the last one is configuration. So my general advice with this is to not reinvent the wheel. I've given this talk maybe 20 times in the last 2 years, and almost every time someone has come up to me afterwards and said, we're doing microservices and we created our own event bus. My first response to that is, that's really cool. You probably should not create your own event bus. No offense, I'm sure you're a great engineer, but these problems have been solved. They seem really interesting and cool to solve. It's the type of thing that would get an engineer very excited to say, ooh, I know how to do that. I know how to do publish and subscribe, and I'll write events into a database, and I can do this to make sure that guaranteed delivery works. I guarantee you will not do as good a job as Kafka or Azure Event Bus or any of the other services that exist out there that already do this. Same thing for logging. There's a logging library called Seq, S-E-Q, that is built for doing distributed logging. It's built to be loosely coupled, fault tolerant. It can queue up events even if the storage, the place it's storing the logs goes offline. It can store them for a while and then write them when the log becomes available again. And most importantly, it's technology agnostic, which means you're not tying in all of your teams to some particular technology stack by saying, oh, we created our own logger class in C#. Now everybody has to write their microservice in C#, right? Or we created it in whatever language but put it in NuGet. Now you have to do it in .NET. You can't write it in some other language. So don't reinvent the wheel when it comes to these cross-cutting concerns. There similarly are things out there for authentication and authorization. I'm sure you've heard of OAuth and those types of things. And logging, I recommend Seek. And there's other services out there for configuration as well. Number 7 is the use of synchronous communication. This is maybe the worst one. So I told you that story at the beginning of a client that was coming to us with a microservices application that was performing poorly. Their biggest problem was this problem. They also had a bunch of the other ones we talked about, but this was the main reason why their system performed so poorly. So just give you an example here. Imagine you have a orders service and a customer service. These are in separate microservices from each other. Your orders endpoint wants to take an order. It might get a customer ID, and it needs to look up that customer's billing address and mailing address and whatever other information you need for the order. So it's really tempting to do something like this, where you start out the order, you say, oh, I need to look up that customer. I'm going to do a HTTP call or a call to this database to get that customer data. While you're obviously waiting for that customer data, the orders service is blocked. And then that customer data comes back. In an ideal situation, that customer ID is found and that customer comes back and you can process the order. Now, if you're only having one concurrent user, this works great. And so usually when you're developing and you're testing this on your development environment, no problem. Imagine what happens when this service either goes down for maintenance or has some sort of an issue or slows down significantly because of load. Now your order service is blocked, maybe forever if the customer service is down. Maybe it's just blocked for a lot longer time because the customer's service has gotten busy. This is actually what happened in that application I was telling you about. And it basically leads to this situation where if you have arrows between all of your services, where every service is relying on several other services, and one goes down on purpose or on accident, then all the ones that rely on that are now either slow or down, and then all the ones that rely on that become slow or go down, and pretty soon you have nothing working anymore. This is exactly what happened in that application I was telling you about. One single service would get slow, and it didn't matter which one it was. It could be any one. Whatever one you started hitting the most, we started doing some load testing on that application. We would just hit any one service. We would randomly hit one with some load, and all of the other ones would slow down within about 30 seconds. And it was because of this situation. Everybody was waiting for everybody else, and so this is obviously not really a microservice because these are not independent from each other at all. So there's obviously lots of great alternatives to synchronous communication. Asynchronous service bus or queues are an important way to do that. It's probably the best way to do it. Another one is through polling. It's an option that you can use. There's also a pattern called the circuit breaker pattern. I would recommend this as maybe like the worst case scenario. If you absolutely have to call from one service to another service synchronously, you can at least use a circuit breaker pattern. The idea of the circuit breaker pattern is you write some code that wraps around that call, and it keeps track of failures. So if there are 5 failures in a minute calling service X, then that wrapper class will actually shut down and say all calls to service X are going to be disabled from now. I'm just going to return an error every time, which then at least speeds up your application. It starts getting errors back right away instead of having to wait for service X to respond. Problem number 8 is a really nefarious one, and that is actually coupling your microservices to each other through the events that they've published. This might even not seem possible to you at first blush, but I've seen this happen. So basically the idea is that your services should actually publish events that say, hey, this just happened in this service. If anybody else who cares about that can do something about it, here's some data related to that event. Well, what happens later when the service that's publishing that event decides they need to make a change to that event, right? well, now there's a potential to break all those services that were subscribed to it. So there's some very basic rules that you'll find published a lot of different places that talk about what to do to make sure your events don't break. One of them, the first one, is rule number 1, no new required fields. So don't create a new field that's required on an event. All optional fields if they're new. So once an event has been published the first time, from then on, any fields after that have to be optional with a documented default. Second rule is anybody subscribing to something that sees an unrecognized field should just ignore it, but keep processing, right? So like, well, that's a new field. I don't know what that means because when I was written, that didn't exist, so I don't know what to do with it. I'm just going to ignore it. But if I'm going to publish an event about what I just did, I'm going to take that data and I'm going to forward it on in my event so that everyone else who might know what that means knows what to do about it. Rule number 3, consumers of optional fields use the default values when they're missing, right? So if you get a data field on an event that you weren't written to know what it means, you're going to pass it on, but you're also going to use the default values, which should be published in the event. And then the last one is if you cannot satisfy all 3 of those rules, you need to do a new event that maybe has a new required field. The solution to that is to create a new type of event, which means that you might have to publish 2 events now. Going back to my hotel example, every time a new room is added, maybe you've got room created 1 and room created 2, right? Because now there's one that has some new required fields that some services know about and some don't. I often get a question about how do you handle, like this creates a big mess, it seems like, how do you handle this? If you do true microservices and you have actual separate teams working on them, my recommendation is to have sort of like a event council that has a representative or a project lead or chief architect or whatever from each of those teams that meets on a regular basis and talks about these events. Maybe a day comes where you publish a new event and you can tell everybody about it. Maybe they want to put that in their backlog to handle that event with some of that new data in there. Or maybe the day comes when an old event that you were publishing isn't subscribed to by anyone anymore because it's been replaced and you can actually turn that off. That's something that you would find out in an event council where you go maybe once a month and everybody talks about what events are being published in there. Problem number 9 is not automating the build and release cycle. You wouldn't believe how many companies, maybe you would, still don't have automated CI/CD pipelines. But when we have a client come to us and say, hey, we're considering microservices, this is one of the first questions we'll ask them. The very first one is why do you want to do microservices? And making sure they have a very good reason. The second question is, do you have automated build and releases? Because if you don't, you're kind of avoiding the whole benefit of microservices, which is the ability to update these things frequently and independently. And if you're doing it manually, that's very time consuming and it's very prone to error, human error, especially with things like configuration or releasing to the wrong environment at the wrong time. You want to have all of this stuff automated first before you even think about implementing microservices. The last one, which I've alluded to several times throughout the talk, is mismatched teams. I mentioned that Google defines microservices architecture as both an architecture and a team organization. And you might be familiar with something called Conway's Law. Conway's Law, to paraphrase it, basically says that a team that builds a system will build a system that looks an awful lot like that team. The common example that's always given, it's a bit of an old-fashioned example, but it's if you give 4 teams the job of writing a compiler, they'll write a 4-pass compiler. Nobody is going to volunteer and say, well, the work our team did isn't really necessary because it mostly overlaps with the work the other teams did, so go ahead and just throw away what we wrote and just use yours. If you have 4 teams, you're probably going to get 4 stages to your compilation process. The same applies to modern applications. If you're building microservices, but you're building it with 1 team, I can almost guarantee that somebody is going to fall for the temptation to put data in a shared database or connect directly through a synchronous HTTP call or connect directly to another database or something like that, because everybody knows the whole application, everybody works on the whole application. This is really just not a good fit for microservices. If you have one team of 5 or 6 people and that's it for your whole organization, it probably doesn't make a lot of sense to do microservices unless each person is doing their own totally independently of each other. And that doesn't make a lot of sense. So I would say if that's what your team looks like, probably microservices automatically are not the right fit for you. You want your team to look more like this if you're doing microservices. You want to have a team for each microservice. Now, I'm not a purist. It doesn't have to be 100% like this. You might have 2 microservices that are a little smaller, and they can be kind of grouped together and assigned to a single team. But the idea is that every team has their microservice or microservices that they're in charge of, and there's really not a lot of cross-contamination between those. All right, so that brings us to the end of my list of 10 things. So hopefully what you're going to walk away from this with is that monoliths can be good too. You can actually scale those if you need to. Microservices are great for the right type of applications, but if you don't have a really good reason to use them, they're very dangerous, and there's a very good chance you'll build a distributed monolith. Even if you think microservices could be a good fit, if this is a brand new application, consider building it as a monolith first and then migrating it at some point in the future. There's a lot of advantages to using that process. If you have a single team that's small, probably a monolith is the best fit for you. If you have a large team where it would make sense for it to be split up into little groups, then maybe microservices is a good fit for that team. And then finally, when you are implementing microservices, hopefully you remember some of these 10 common mistakes that I showed you to make sure that you don't fall into those same traps. So that brings us to the end of my content, and we've still got a few minutes left. So I know there's some microphones in the back, and I'd be happy to take any questions that anyone is willing to say out loud in front of everyone. Any questions I can answer? You can just raise your hand, or, yep, there's the microphone is ready. Any questions? I answered everyone's questions so perfectly in my talk that you don't have any questions. All right, well, if you think of something and you want to chat afterwards, I'll be up here for a little bit before I have to hop on a train to Lisbon. But you can also reach out to me at any of these places, or feel free to use this to join me for my office hours. I'd be happy to chat with you at some time that's convenient for both of our time zones. Thanks so much for coming to the talk today. I hope it was useful for you.
There we are. Hey, you can hear me now. Excellent. Thank you for coming. I'll just let the last few people come in. Do you like that? Who here is from Porto? Actually from Porto. There's like 2 people. Thank you. This is an awesome place. So I went out earlier today because it was not raining for about 6 minutes. And I did a few drone shots. It's just such a beautiful area. Like, I couldn't help myself. So thanks to the people of Porto for putting that on. All right. A few more people coming in. Come on in. There's plenty of room at the front as well. Yeah, I know. I'm going to get you a bit out of your comfort zone today, but that's okay. So, see people? Yeah, this is front. There's actually no one sitting in the front. I don't pick on people in the front much. All right. Come on in. We're all friends still. Okay. Hi. I'm going to talk about a whole bunch of stuff that I've done in the past 10, 15 years, I reckon. And I'm glad you're going to be part of it. So this is a very participatory talk, as in you're going to be part of it, because otherwise it's about a 12-minute talk, I think, roughly. So I need you, okay? This was my clickbait title to make sure you came in the room. It worked, obviously. But there are a couple of disclaimers first that I just want to go through. This is my talk. I do not have all the answers, right? So, and it'll become evident why I say that as we go through today. This is just my subjective opinion on most things. And I want your opinion too. That's the beauty of subjective things, is that we can all have our own opinion about them. Take what you can use and leave the rest, because any advice, and this is a whole bunch of stuff that I just regurgitate because they've helped me, and then you don't have to screw up like I did. But if you don't think it applies to you, that's fine. It doesn't have to be, but maybe you can take at least one thing away, right? So I don't have all the answers. That's the main one. Ask lots of questions. Seriously. We have the lovely, I forgot, what was your name again? Yes. Sorry. We have the dude in the green. Sorry. Sorry, man. No, he's got a microphone, so if you want to participate, and someone has to be first, okay? See? There's already one. No, we're not doing it yet. Nope, stop it. But he'll gonna come with the microphone, okay? Because we're recording it, we're streaming it, so make sure people can hear your question, or comment, or whatever. And do... There's always one. Don't ask about Lego or cars. We are going to talk about cars. We're not going to talk about Lego because I will not shut up. Just saying. Okay. So I'm going to start with where I'm at, okay? Because that's not a look at me, right? This is more of a I have got to this point now in my journey, and that's relevant to the rest of the talk. And maybe you can relate, okay? So I'm going to talk about just briefly where I'm at. So first of all, I get to live here. Well, I'm not there, but that tree is on my property. Right? And I do live in Australia, but I am Dansk, if there's any Danish people here. But I've lived in Australia for 20 years. But now I live on a farm out in the middle of pretty much nowhere. It looks sort of like that. And it's a choice. And again, I'll come back to more of this in the talk. So we moved there a while ago. It was part of a plan. That's where I'm at now. That means that my son can grow up in an area where he can go to the creek with a dog. And he does Minecraft for real. Well, that's what he calls it. So he gets a shovel and goes and digs holes, or a pickaxe, which is great when you're 8 to have a pickaxe, but that's a different thing. Right, but it's a conscious choice. I work in a fantastic company. I was actually laid off 2 months ago. So my talk has changed a little bit since then, but it's all part of my journey, right? And I work for a company called Arcana, which is in Perth. And the cool thing is that I am the marketing budget. So I kind of get to do sort of what I want, but I'm a developer as well, right? So it's kind of I don't know, it's a mix. It's fantastic. And I can talk much more about all these things. I am writing a book, and more of that later as well. That is one of those things that I've always wanted to do, is to actually put words on a page and try and figure out how the hell this thing works, right? I don't actually expect to sell any as such, because I know tech books are not a way to make any money, but I'm writing a book. There's my pride and joy, well, one of them. I'll get back to that quite a bit. And if you don't like cars, don't worry. It's the essence of the idea of why I got it. It's not the car itself that's important in this context. And we have llamas. This is where you're supposed to all go, aww, because everybody always does. And yeah, again, I can talk much more about llamas. All right, so, and I get to travel. I forgot that bit. Yeah, because I'm here, right? Which is cool. So how many has traveled from outside of Europe to be here? Because I know there's, see, there's 1, 2. Okay, where from? Do you want to, where did you? Accra. Where's Accra? In Ghana. Amazing. Like, seriously, this is cool, right? We get to do this stuff and we get to travel. Okay, so this is, can I move this? No. So, just as an incentive, because I do want you to participate, I have, for people that have great questions or comments, I am allowed to give away books. I haven't actually finished the books yet, so you get a virtual copy. But it is, you can follow the journey. I'm at like chapter 9 out of 12 or something. Someone was there, but you get to then read it, you get it, etc. Right? So that's my carrot to you to participate. Not that you probably need it. You look like a keen bunch of people. Okay, I'm going to start with a few questions, and you can just put your hand up to start with, or not. Again, it's sort of voluntary. But this is a very broad question, because it means something different to everybody, right? But who here can say that they are genuinely happy in where you are? That you're like, I'm done. That's pretty good. That's about 8 more than normal, right? Because if you're not, why not? Like, what it is that you require to get there? Like, why are you not at that point yet? And it's a really good question to keep asking yourself, like, okay, I didn't really like that. Why didn't I like? Why am I doing it? Right? I love being up here talking to you, so I keep doing it. Right? If I didn't like it, I wouldn't do it. Have you set goals? So just show of hands again. Who has goals? Who has actually set goals? If you're not, are you familiar with the concept of goals? Does anyone not know what I mean when I say that? Okay, there's a few people. Okay, cool. And I bet you half of you actually don't have goals, but we'll get to that. Told you I'll get in your comfort zone, out of your comfort zone. And who thinks that the grass is always greener somewhere else? Like, who looks at someone and goes, oh God, why are they doing all that? How do they get time? I wish I could do all that. Oh, that's a great job. I wish I had that senior role in, what was it that Steve said this morning? Surveillance-driven development. That's a fantastic term. Right? Does anyone think that? Considering most of you said you're not happy. Okay. Right. So just bear those questions in mind as we go through this. I'm going to have to move this a little bit, sorry. Otherwise I can't see any of my notes. Cool. So now we get to the bit here. Who has a dream? Who wants to share a dream that they've got? Someone's got to be first, not you. Come on, anyone? I'm just going to stand here for 40 minutes otherwise. There's always someone's got to be first. Anyway, just shout it out. What's a dream? Something you would love to do? Win a world championship. That's definitely a dream. In what? Brent? Can we get audio on the mic, please?
Cyclocross.
Say again?
Cyclocross. Biking.
Biking, cycling.
Yeah.
Aha, okay, cool. Yeah, fair enough. That is a dream, right? And I'll get to why that is different from a goal. And then I still have this in here. I put no bigger ones, but that's a pretty freaking big one. And the first time I did this, right, was in the Netherlands. I asked someone, oh, you got a dream. Yeah, I want to get married. And then I put that up. I'm like, oh, shit, right? I wasn't, but every time it works, so I just kept it in there. But no, dreams are important, but they're not, they're not as important as you might, well, we'll get to that. So I'm just building it all up now, right? I'm setting the scene. So, who wants more time? Yeah, exactly, right? We're all like, oh, I wish eBay sold more time. Damn it. So then the question is, what do you want more time for, and why do you need more time? Right? Because it's easy to go, yeah, of course I want more time. I wish I had 2 extra hours tomorrow, right? Or whatever it might be. But we all have the same amount of time. I have the same amount of time as any of you. There's no difference. So why is that in such a thing that we always says, I want more time? It must be because we want to go where the grass is greener, right? Because you weren't happy. Kind of all relates now. Now, on the concept of time, here's my favorite bit. Who has a Netflix account? Yes, exactly. Or a Disney Plus account? Or what's the next one? Stan? Probably not, because that's an Australian streaming service. Anyone has Stan? No. Oh, that's good. Or Foxtel, which is another one thing in Australia, or cable, right? So now I'm going to ask someone, what was the last TV show or show you saw on Netflix? Or Disney Plus, or whatever. Anyone? Come on, just any show that you saw. Okay, there's one in there. Just do that so we can get everybody with it.
Better Call Saul.
Better Call
Saul.
Saul.
Yeah, Saul
That's
Goodman
it.
from Breaking Bad. Yeah, Better
Okay.
Call Saul.
No, keep that. How many seasons are there in Better Call Saul?
I think it was 6.
6, right? See where I'm getting with this? How many episodes in a season?
Between 10 and 15.
10 and 15. And how long is an episode?
About an hour, slightly less, 45 to 60 minutes.
So let's say an hour. Maths makes it easier. Okay, so you've watched Better Call Saul for 15 or 12 hours times 6 seasons. So that's what, 130 hours?
Yeah,
Yeah,
let's say
so roughly a month worth of working weeks.
yes.
Yeah? Okay. What has that given you?
Entertainment.
Okay, sure, right? Could you have got the same entertainment in half that time?
Possibly.
Possibly, right? Does anyone not get what I'm getting at here? There are things, and I pick on these specifically because I know us nerds have these services, right? It's a very common thing, but my God, it's a trap. Because you just watched 6 seasons, you might not have done it in one sitting, but some people do, right?
Let's not get into that.
Exactly. And you just spent 100 and whatever hours we figured out, right? Don't put me on the maths. If you hadn't watched it, well, you've had all that time. So what are you really asking when you say I want more time?
Probably could have slept better.
You could have slept
Yeah.
better, okay? Also important, also important. But the whole point is that we spend so much time on, let's pick on these, let's say Netflix, even though I mean all of the streaming services, and we spend so much time on it, like unbelievable amounts of time, because we just got to watch the next one. There's a reason they can cut the credits and the intro, and so you just keep going, right? And it's just a challenge. Try and maybe cut that out for, say, a week or a month. Just don't watch it. And see what else happens. The first week, you're probably going to go, I'm bored, maybe. But you also find that you have oodles of time. So, and this is, again, this is not me just telling you what to do. This is just, I don't have streaming services very intentionally. Okay, I'm lying. I have Prime because it comes with Amazon. But I don't use them, right? And then what's the next question? So I say, okay, why do you watch it? And you just already said it, entertainment. Or what's the other one? What's the common excuse for watching lots and lots of streaming? What was that? It's cultural. Okay, I hadn't had that one before. That's not bad. So when you say it's cultural, what do you mean?
Well, everybody watches TV shows, and you want to talk about them when you're with friends in dinners.
Okay. So that's all you can talk about?
I'm sorry?
That's all you can talk about?
Of course not.
Of course not, right? So in that case, the other thing that normally comes up very often is that, yeah, but I need to relax, right? Hang on, I can't hear it. We probably need that because the echo is a bit. Just grab the mic. Just grab the mic there.
Okay. You want to relax, actually.
Want to relax?
Yeah.
Fair, sure.
You don't have energy to do something active.
Okay. Why do you need Netflix to relax? Why do you need to watch
it's
3?
It's good to get out of your head, actually.
Okay, sure, but
You're looking at another person's history,
Yeah.
actually. It's relaxing, I guess.
it's what's her name?
It's relaxing.
To relaxing, yeah. And
Instead
that's
of-
always the, like, I need to relax, I need to turn my brain off, I need to do something where I don't, because we all have quite intelligence, not what I'm trying to say, brain-intensive work, right? We all have cognitive exercises all day, and I get it. But what if you were, say, you could watch a movie once a week? So I use movies a lot because movies end, right? You spent an hour and a half, you spent 2 hours, and it's done. There is no season 3, unless it's Lord of the Rings, then you're in for 12 hours. But anyway, and it's not perfect, but I get what you're saying. I understand, and it's not that simple. But my God, these things are just such a time hog. It's incredible how much time you, in my opinion, waste on this crap. And you said, oh, it's cultural, I need to talk to my friends. I'm like, really? Are you sure you need that? Because I don't have any friends. Wait. No, you know what I mean? There are so many other things that you can use your time on. So in my case, I use, say, a movie once a week because I enjoy movies. I used to work in movie theater, yada, yada, yada. But I promised I wasn't going to say it. Anyway, Lego, right? That's just my thing. And I do it with my son on some of the time. Some of the time it's just me. Some of the time I'm on the floor playing with it. But, no, there are so many other things. It's just that we do this because why? Come on. It's easy. It is the easiest thing in the world. And you sit down on the couch and you go, that's it. And that is why. So I just, again, challenge you. Try and cancel your Netflix account. That's extreme. But don't use it. And I bet you'll find you have other things to talk to your friends about. And it is a conscious decision. And there are conversations I can't participate in. But that's the same with many other things that I don't know anything about. So I don't see that as a loss. So I get it. I get why people do it, but I also think that you can do so much better. Anyway, I do like this point. I don't know if you noticed. Anyone want to comment on that or challenge that? Yes. Hang on. Let's go make sure we get everybody along here.
So if a lot of people cut Netflix and streaming services, how are they then going to escape from reality?
See, that's a whole different talk.
I'm joking because people talk about passing time.
Yeah.
So they have too little time and too much time at the same time.
But why can't you talk about a audiobook you listen to? Or in my case, Lego is something many people do. Or why can't you talk about the project you're doing, extending your living room? Or there's so many things that you can talk about where you can escape from reality and go into someone else's world, right? Doesn't have to be. Michelle is very, very keen.
I just want to, why are those other things okay, but this isn't okay? Why is it okay to spend all my time reading a book, for example, or playing Lego, but this is not okay?
That's a very good question. I like that. Thank you. You get a book. The reason that this is not okay.
I already bought the book.
Is that you get nothing out of this. Nothing at all, right? In my opinion. Again, this is my opinion, right? You don't have to agree. But there's nothing you get from this that you can use for anything else other than, say, talk to your friends, right? If you work in movie and television, okay, maybe there's more to it. But for the rest of us, no. And you end up spending 100 hours, 200 hours on stuff that you don't even remember much of because you want to be entertained, right? So that's my argument. Yes?
What about watching documentaries?
Documentaries, right, but they end. You don't have 16 seasons of 14 episodes per...
Well, sometimes you do.
Yeah, but they end. They're very finite. I don't know any documentary series that has, and next season we're gonna, unless it's reality TV and then it doesn't count. Right? But no, yeah, and you got to find your own balance. This is not black and white, even though I'm trying to make it black and white. Of course it's not. But just consider it. All right, I'm gonna have to move on, even though I could talk about this all day. So that brings me to my next point. And this is one of my favorite words, and it is in English. I'm sure it can be translated to other languages, certainly Danish, is that be intentional. Favorite words, it's 2 words, but anyway, intentional, right? And this is, anything I do is with intent. I am here with the intention of trying to get you out of the slump, if that's where you're in, or give you some inspiration to do more things or chase your goals, right? The intention is so important. And I don't think, going back to Netflix, that when you watch something, it's with intent. It's because you can't be doing anything else. That's just, I'm going to stick to that. But if you're intentional about the things you want to do, you start actually achieving these things. So the intent is such an important part of it. And that word, every time you do something, it's like, okay, why am I doing this? What's my intention of doing this thing? Right? And it doesn't always work, again. But if you start using intentional words, like intentional, then you just find your journey gets much more, not structured, but you just start seeing the end goal or seeing the long journey. No, not that goal. Sorry, that one. Who has goals? And now I want to talk about goals, because that's such an important part of what we are as humans, what motivates us. Just anyone. Okay, up the front here. Who's first? See, now we're getting somewhere. It's good.
Yeah, so I want to write a book.
You want to write a book? Fantastic. So I'm going to argue and say that's not a goal. That's a dream. Yeah, why? Exactly. Good point, right? So on what topic?
So I was contemplating on writing a book on writing your own game engine as a weekend project.
Game engine, very good topic, like it. When are you going to write the book? When is it going to be finished?
Don't know yet, I just started the first chapters.
Cool. And that's why it's not a goal in my definition of a goal. Because unless you make it absolutely intentional when you're going to finish it and what the topic's going to be on, etc. in this case, well, what's stopping you from going, I'm just going to watch Netflix instead?
Well, if I don't want to watch Netflix, then I want to write.
Yeah. But so my point with this is that it's good though. Don't get me wrong. I do like it, and thanks for volunteering. If you don't have an end date with this, if you don't know when your chapter 2 is going to be done, when chapter 4 is going to be done, and when you're going to do the final review, well, what's for stopping you to go, I'll just do it tomorrow. Now I'll just do it next week. Oh, pub, yeah, absolutely, right? It's very easy to get out of it because you're already giving yourself an excuse, saying, well, I don't have a deadline. But it's about intent. What if you don't need a deadline? But then why are you doing it? No, you don't need a deadline to finish it. I agree. But you don't know when you're going to finish it, which means it's going to be forever on your plate, possibly. Right? And the whole idea with goals, in my opinion, is that that's very firm when you're achieving certain milestones. Yes, sir.
What if you have two conflicting goals?
Conflicting goals?
Yeah, for instance, you want to write a book.
Yep.
You have a plan, but at the same time, you want to invest some time, extra time with your family.
Sure.
You have emergencies, so you give yourself like a day off to be with your family or whatever, friends.
Yep.
So it's two conflicting goals. One part is your own success, the other is socializing.
But I see. I don't think they're conflicting. I hear what you're saying. How do you make it all fit? I don't think they're conflicting. You can absolutely have more than one goal. Of course you can. You can have short-term goals, you have longer-term goals, in my family, we have a goal that is massive. Like it's 6 years down the track and it requires maybe 60 different things to line up, right? But I have all these other little sub-goals, like something to do with cars, etc., something to do with our house. And the reason, back to your question, is that you need to figure out what is most important to you, right? And family, obviously. I don't think I'm wrong in saying that always comes first. But you also, so in my case, I want my son to see that he is not always going to be the attention, like he can't always get the attention because there are other things that I need to achieve for me and give him that inspiration. And that's just the way I see parenting. I'm not going to tell you how to parent your children. That's not what we're here for. But I find a way where I can do both because both are really important. So I don't think they're conflicting. It's a matter of time management, which is a whole other talk as well. Did anyone else want to pipe in? I thought there was a hand somewhere. No? All right. Oh, yeah, you can. We've got time.
I want to buy a piece of land on which I will build a house.
Nice. Good one. Right? Housing is important. It's often one of the goals we have. Have you considered where you want this piece of land to be?
Yes, it's been an ongoing topic since the beginning of the year.
Nice. Yep. Okay. And you have some sort of idea of when you're going to be able to purchase the land?
In the next 12 months,
there you
tops, I would hope.
Right. But you're getting very close to actually achieving that sort of time frame, is what I'm hearing.
Yes, from my side, but it also depends on plenty of other factors, such as people from which I'm trying to buy it from. But we don't want to get into that.
No. But you're making a good point. There's always changes. You can have the best plan for your goal and whatever, but there's always going to be changes without fault, and we just have to manage those things. I did not intend to be laid off at the end of July. It was not part of my plan. I wasn't actually going to go anywhere, but here we are, right? So plans change all the time. That's just being human. So yeah, you say, well, and the important thing you said within 12 months. Then you work towards that, and you have to make assumptions, some things, and you're going, okay, well, they're probably going to sell it in 12 months, whatever the circumstances might be. But if that doesn't happen, then you have to adjust, but at least you have the goal to start with.
Yes, I
right?
agree.
And it's such an important thing. So I'm hoping that makes sense, is that these things, that's a rocket, these things are really important in your life, whether you have 1 or 10 goals. Probably don't have 10, please. That gets really, really complicated. But they're so important. Okay, I'm going to talk about 2 of my goals so that we can sort of quantify it a bit, right? Because I think goals need to be quantifiable. You need to know when you've achieved them. And here's the car again. Right, so if you're not into cars, that's totally fine. But this was a goal that me and my wife had. When was that? 2020, roughly? That we both into cars. I love cars in many shapes and forms, but we wanted something that had very specific criteria. So 7 seats, very loud, very fast, very large, et cetera, right? I actually had loud on there. I'm one of those guys, I'm sorry. But we went through and we researched a lot of vehicles that would fit these criteria. We figured out roughly what they cost. That turned out from new is $250,000. We went, we're not buying a new one, right? So you within our means, etc. But then we had it'll take us 18 months to figure out how to get enough money and how to finance it and where to put it. And so we were very particular about cars. So there was a long list of demands that we needed to sort of fulfill for ourselves. But we did. And we ended up buying it after, I think it was 18 months. I can't remember the exact timeline, but it's about 2 years ago. And it was just such a sense of achievement because when Fiona first said it, I'm like, what? Are you mad? Like the amount of money needed was like, this is crazy. But I wanted it. I'm like, okay, we've got to find a way. And again, the point is not the car. The point is that I've wanted it badly enough that I've made a plan and we made it happen. And then I can be snarky and say I wasn't watching Netflix while I did it. I won't go into Netflix again, I'm sorry. But it's one of those things that, for me, this was like, eureka moment. It was just such a sense of achievement that when it arrived, actually on a tow truck from Queensland, which is, it's like driving from Toulouse to here, roughly. Like a long way. And we could follow it, and it was very good. The fact that we got it, and we have it still, it's the best feeling ever. So if you don't have goals, start with something you can celebrate, because that's one of the really important parts, is that whenever you achieve something, celebrate it. The other part of it is that I've run a YouTube channel. And I've done video for a long time in many different formats. So it's training as, mostly educational, but all sorts of different formats of video. And in January of 2021, I thought, no, I'm going to either do this or not do it, and I'll do it for real. So I set a goal that every 2 weeks I was going to release a video, and in my case, it has to do with network equipment and home automation and other things. Doesn't matter. But every 2 weeks I was going to release a video, no matter what. Because otherwise, I was like, I'm going to find an excuse. I'm like, I'll just do it next week. Yeah, my leg's really sore. I should probably, you always find something. But if you set that goal and say, no, every 2 weeks, I'm going to release a video. And then, of course, that's not enough. So I'm like, okay, well, I want to get to 1,000 subscribers. And the main reason for that is that you can monetize it. You can start making income off ads and other things. So that seemed like a good goal. So I achieved that in 9 months. I think it took quite a while. YouTube's hard. We all watch these YouTube channels that have millions of subscribers. That's not how it works. I don't know how they do it. And then I said another goal was that, well, I want 10,000 subscribers. And I want that by the end of 2023. And guess what? It happened last month. It's very cool. I ended up with 10,000 subscribers. Yay! Thank you. No, it's just, it fills me with joy because it was, at the time when I set that goal, it was like, holy crap, I did 1,000 in 9 months. How am I going to do 10,000 in like another year and a bit? It seemed impossible. But because I didn't give myself a way out, I was like, no, I'm going to make it work. So the secret sauce for me to do this was I actually ended up, the money I made off the ads, I put into ads for my videos with a subscribe button on it, because YouTube does that. And that worked to some extent. So you find a way, because I wasn't going to let go of the goal, right? So those are two things that I achieved that I'm immensely proud of, to be honest. Okay, anyone want to, in relation, once with that, oh, Andrew. I get him to run. All right.
There was two types of goals in your YouTube example there.
Yep.
There was the goal which you were in direct control of achieving, which was to release a video every 2 weeks.
Yes.
There was nothing really stopping you from doing that.
Correct.
And then there was another type of goal you had, which was to achieve 1,000 and then 10,000 subscribers. Yep. They're goals in which you can't directly achieve that yourself. There isn't a very specific pathway between the action you take and achieving the goal.
Yep.
Can you talk to the difference between those? Because I have zero problems with the first type, setting goals in things that I can achieve. But I actually can find the second type of goal demotivating. Because if I can't achieve it, then I feel like I'm just always struggling to achieve it. So I always find myself only setting the first type of goals versus the second.
So you stop challenging yourself. Sort of.
It's not the challenge. It's the first type of goal is something you can do, and you can be sure that the only thing stopping you achieving it is your own hard work.
Sure.
You could work every hour of every day for 12 months and never achieve the second type of goal.
That's fair. Do you all understand what Andrew's saying? So there's the goal. Well, you were saying as well with the block of land, someone else their actions have to be part of it. So if you find that demotivating, perhaps there are you haven't set enough milestones to how to get there, possibly. What I find for me is that they motivate me a lot more, because I know I can do one every 2 weeks, and who cares? Me, right? No one else cares, really, which is also important. I mean, I have to achieve it myself. But the other part of the goal, where you say it relies on other people, which is almost always the case, by the way, is that you then have to find out what makes it work, right? And that's why goals are so important, because they're supposed to be hard, right? Don't have a goal going, I'm going to go home today and make dinner, right? That's not a goal. Like, anyone can do that. Make them difficult. And the fact that that motivates me is that I need to figure out, like, I was way behind on my 10,000 subscriber goal. Like, how do I do this without cheating? Because yes, there are services where you can buy subscribers. Please don't do that, right? For me, that was okay, I've got to find a way. What is the secret sauce? And often when you do that, it forces you to see things differently. So in my case, it was like, oh, there's a Google ads for YouTube? Sure, I'll pay some money to achieve my goal, right? So I hear what you're saying, but I'm wondering if it's because you then go, no, I want 1 million subscribers. Oh, that's really hard. I'm not going to do it, right? If you start like way ahead, instead of going, well, I need to get to 1,000, and then maybe whatever your measurement is, right? I don't know if that answered the question, but don't. Here's me being on stage going, don't let that discourage you, which is very easy to say, because it is hard. These are not supposed to be easy, by the way. That's why I chose a rocket before. They are supposed to be hard. But I understand what you're saying, and I'm wondering if when that happened, you go, oh, I'm not getting anywhere. If you then reevaluate your goal, because that's fine, and you say, well, maybe I'll scale it back a bit to something that I think I can achieve in the same time frame. And again, don't make it too easy. Does that answer your question?
I think so.
Okay, cool. There's a finger pointing. Cool, thank you. It's awesome. I did say it was going to be a short talk if you weren't participating.
It's in a way a follow-up to Andrew's question. If even when there are things way out of your control, shouldn't stop you from making goals, is there then any prospects that you shouldn't create as a goal that would be better to keep as a dream than a goal? Or is your opinion that you can make absolutely anything into a goal?
Yeah, you can. It just depends how important it is to you. like any dream, as I keep calling them, are important. It's important to have ideas of what could be possible and things you'd like to achieve or accomplish. But they're dreams until you put them on paper and you start going, okay, well, I need to do this and this and this and this. I don't think there's goals that are too big as such. There are goals that are too big to do in one go. And I'm certainly in that bucket with one of mine. So I've split it up into like 6 different things, because otherwise it'll never happen. Right, so you need to reevaluate, and that happens all the time. Like you go, I'm not actually getting anywhere. Is it because I don't care, or is it because I just don't know how to start or how to achieve it, right? You got to sort of figure out what the problem is. But it's a good question, because my next slide was about The Martian. Does anyone know, does anyone not know this movie or what it's about? Okay, a couple of people. In short, Matt Damon plays an astronaut, gets stranded on Mars, has to do a whole bunch of sciencey shit to survive and go home. That's the gist of it, right? It's a very good movie if you like space stuff. And it's relatively realistic. Now, the reason I put that up is that for the people that have seen the movie, how does he survive, spoiler alert, on Mars? Do you remember the line from the movie, anyone? No? He says, I'm going to have to science the shit out of this. And what he means is that he's going to have to solve one problem after another. Right? Okay, what's the immediate problem? This thing. Okay, well, I've done that. What's the next immediate problem? And he keeps doing that. And how that relates to me, I think, is that we bought the farm. Right? So this is where we live in Australia. This is a prettified version with flowers. Right? And the way that we got that farm was, so the short story is we signed the lease or the contract. I don't know if it works the same in every country, but in Australia you sign a contract and you have sometimes some conditions on there. We signed this unconditionally before we could afford the place. Right? So we actually signed the deed saying, yeah, we're going to buy it without knowing how we were going to buy it. And then we applied that Martian technique. Okay, what's the first problem? How do we even start this? Now, it wasn't completely like, I'm not a cowboy. There was some calculated risk in it. It's a good video, isn't it? There's some calculated risk in it, is that we had some idea of how we were going to secure finance for it, but we didn't actually know. So we ended up going through a whole lot of different legal loopholes and figuring out which bank would talk to us, and et cetera, et cetera. There was a whole range of things that we had to do, but there was no way in hell we were not going to live there. We made the intentional decision. The intent was we're going to live there, and we weren't going to budge from that. That was why we signed that unconditional contract, right? Who thinks that was stupid? There's got to be some. Yeah, thank you. Okay, good. Because there are always people that are like, that's too much risk. And you have to find your own sense of calm with this as well, right? It's not for everybody, but it's just one example of how I applied the Martian technique, as I call it, like just one problem after another until you get to the end. And then when we finally got the keys, it took 9 months. Holy crap, like that was just the best thing ever. And we did buy the worst place on the best street, I think. Like, what a dump. But just, we spent 10 years now renovating, basically. It's all worth it, right? It's all worth it. All right. And in fact, we're never going to say goodbye to that place at all. You like them? Llamas. I told you there'd be llamas. All right. So, sometimes you make mistakes. Actually, I make a ton of mistakes all the times. The example I normally use is that I used to work for Pluralsight, which is a training platform, and I was doing a course a long time ago in something called play-by-play. 2 people get together, they record a video about a topic. It's loosely scripted. One person is the educator, one person is the student, and you teach that other one on camera, and you get stuff out of it. And I was the teacher bit in this one. It's changed a bit. And I was teaching quantum computing. Easy, right? No? Okay. And I thought it was just when Q# came out on the .NET platform. So 2015, something like that. And I was sure I had it right. Like I had slides ready. I knew exactly all the different definitions of super imposition, whatever it's called, all the various terms, right? And we recorded the whole thing, me and the other guy. And it was 2 hours of it. There was full camera crew, so 3 cameras. There was lights in a studio, like big production. That's how they did it. And then about a month later, they get the footage, they edit it all together, they send it off to Microsoft because just for a sanity check. And the feedback that comes back is like, what the is this guy on about? Like, what the hell is he talking about? I got all of it wrong. I completely misunderstood it. Right? Especially the very critical concepts of how quantum computing works, I got wrong. And I'm like, oh, shit. Luckily, they never released it, so you will never see it. Right? I don't even have a copy of it. But it was just at a point where I go, okay, do I try and defend it and say, no, because I think so? Or do I just own the mistake and go, yeah, I screwed up. Holy crap, that was, yeah, I don't know. I must have eaten something I could, like, I don't know. Why did I do this? I was so sure it was right? But instead of trying to blame someone or explain it away, it was just like, nope, I screwed up, I'm sorry. And if you do that, I don't know if anyone don't do that, I'm not gonna ask you necessarily, but what happens when you own your mistakes is that, well, 1, you can move on because you know you screwed up. You learn from it. And 2, it actually often adds to your credibility. It makes other people go, oh, yeah, well, you're not right all the time, but none of us are. And it gives you that credibility of like, they will know when you screwed up because you'll tell them, or you'll admit it if they tell you, or whatever the circumstances might be. So that's just a very important part of it to me. So with goals, I'm sort of trying to not make you do the same mistakes I did. I want to talk about the birds. Does anyone know the concept of the birds? No? Most people never do. It's very interesting to me. So when you have some sort of grand idea, so let's say write a book, right? For example, we'll write a book. That's a good example. And you start telling people, you go, oh, I'm writing a book. It's really cool. I'm doing this. It's about an 8-bit Nintendo, whatever. I don't know what you're doing. And then people go, oh, really? Right, okay. And then people start going, are you sure you can do that? That's really hard. Writing a book is a lot of work. So are you sure you want to do that? And the birds start pecking at you, right? They start coming up and they go, oh, nah. You know, I think you should watch next week. No, they don't say that. I think maybe, like, that's really hard. I'm not sure you should do that. What they're not trying to discourage you from doing it. What they're doing is they're projecting their own insecurity and their own, deficiencies essentially on you. But it's so powerful because often, who does this? Who is it that gives you these opinions? Come on. Friends and family, exactly. Because those are the people you shared with first, right? They're the people that you're most proud to share it with. And it's not like they don't want you to succeed, it's just that they don't think they can do it. And if you keep that in mind, because I've had that many times, like a lot, because my family is completely different to me in a lot of aspects. Maybe that's why I moved from Denmark to Australia. Anyway, just keep that in mind, that their opinion doesn't have to matter if you want something bad enough. It's really, because it's so easy to fall in that trap. Because it could be over months, and so you start doubting yourself, you start thinking, oh, I probably can't do it. Yeah, that's hard. No, I should probably try something easier, right? So just bear in mind the birds, they're always there. And then what you can use is reverse psychology a lot of the time. Yeah, I like that a lot. Now, it's not always that simple, but the reverse psychology part of this is that when people start doubting you, you sort of go, well, what would you do? Like, move it back, turn the topic away from you and try and make them see that it's not you that's doing something that you shouldn't. It's them trying to prevent something they wouldn't do, if that makes sense. Just in one example. How are we going for time? All right. Anyone want to share anything about this? Yeah, I figured there was a hand down here.
To me, those birds are actually motivational, because when I want to do something, I often slack off. But if I tell people this is my goal for the next 3 months, people ask, how are you doing with that? And that helps me a lot.
Yep, that's a very good point. So you're saying I need to tell someone to be held accountable, right? And absolutely. I'm not saying everybody does this. I'm just saying there are certain people that will do it, and they're often close to you. We'll get to that in just a second because it's a very good point, and I am going to get to that. Excellent. So, one of the ways that you can help you get into and achieve your things is getting a mentor. So, who has a mentor or is a mentor? See, there's like 3 people. 4. Does anyone want to sort of share why don't you have a mentor? Is that because you don't know how? Is it because you never heard of it? Is it because you don't need one? Like what? There's no wrong answers, but why? What is the? Just give me something. Wow, I'm about to call you a Belgian audience, and that's see. Hey, did you want to? Or did you have your hand up? I'm not sure. Yeah, cool. Go for it.
I did. So I'm a mentor myself.
Yep.
But I find it very hard to find a mentor.
You find it hard to find a mentor. Okay.
Yeah. And I think especially when you're like more experienced, like you really. It's not that you cannot learn. On the contrary, like I learn a lot by being a mentor myself.
Sure. Of course you do.
But you need to create this connection. You need to relate to, and I'm not sure if that just clicks, but for me it's really hard to really find a mentor.
Yep.
I've tried, but
and that is the #1 reason I always get is it's very difficult to find a mentor, and I don't think it has to be right because where do you find them? Like where do you go? Like because I would start something like maybe at work or well if you want to pitch in, Michelle, because you are one, I know that.
I am one, but I'll tell you where I found one. People, I think people often think it's like, they wander around saying, are you my mentor? Are you my mentor? Like, they're looking for the holy grail of things. And that's, and they're not. Mentors are just people like you and me, they are normal people.
Oh, yeah.
And where I got mine was when I applied for when I got my favorite one, because I have many. I think mentors should be like a board of directors, like get a load of them.
100%. You're stealing my thunder.
Yeah, I applied for a job and I got rejected.
Yep.
And it really hurt and I cried for 3 days. But in that interview loop, one of the people I spoke to, we hit it off. We had an amazing conversation. We sparked ideas in each other. And after I stopped crying, I called him up and said, could we have a call once a month?
Yep.
And he's my mentor now.
That is an awesome story because that is exactly how it should work. Not always does. So Michelle's saying that she basically, through a rejected job interview, she found a mentor. Because you want people to know something that you don't, and everybody does. So you were saying, it's hard when you get a bit more senior. I have a mentor that's 28, right? And I'm not, in case you hadn't noticed, right? And that's totally fine because her perspective on things is so different than mine. So if I go, especially with my book writing, I am a really slow book writer. It's the hardest thing I've ever done. So I talk to her, and she goes, "So have you written any book?" No. Okay, why? And she just goes straight for it. She doesn't have to know what the book's about. She doesn't have to know how to write a book. She just has to know how to keep me honest, right? And that's really what it's about with a mentor. They have your interest in mind, but they're not necessarily your friend. Right? They're not there to have a beer with you, or they're not there to, tell you, it's going to be all right. They're there to give you a solution or a kick up the ass or whatever it is you need. Now, back to finding a mentor, which is always hard, is if you go to a user group. Surely someone here goes to meetups or any kind of technical gathering of people. Ask one of them if there's someone you see that's very good. And the worst thing people say is no. Right? I have, because I do this talk, people ask me occasionally, and sometimes I'm like, no, I already got like 4 people that I'm mentoring. I can't do all of it. And being a mentor doesn't mean that I know all the answers. Again, as the disclaimer said at the start, I don't have all the answers. But what I can do is I can listen to what you want to achieve and poke you and turn off your Netflix, right? That I can do. So get a mentor, however they come. Is it at work? Maybe it's your dad's best friend. Maybe it's, I don't know, whoever it might be. It doesn't have to be in the same industry. It doesn't have to be the same age. It doesn't have to be the same gender. It's just people that want to help you. That is the most important thing. And it's so important. It's really important. Okay, so now back to the gentleman in the back there that asked about how you need to tell friends, right? Because this is about friends. And in your case, I envy you a little bit because it sounds like you have very good friends that actually sort of say, well, how far have you got? right? They have your interest at heart. Because what often I hear people go, oh yeah, but I got to go to Stephanie's graduation, son's graduation or something, or whatever it is, right? I'm like, okay, why are you doing that? Oh, I've known her since high school. No, why are you doing that? And they can't come up with a good reason why they still associate with these people, right? It's just that because I've always done it. And this is probably the hardest part of this talk, I think, is that sometimes there are people that just drag you down. It's just how it is. It's people that either the birds could be it, but it could also just be friends that you feel obliged to hang around because you always have. And all they do is they say work at a supermarket at the checkout. I don't know what, but something that is certainly not in line with what you want to do. And this is it's a cliche, but it's true. You want to associate with the people you want to be like. Right? If you're the smartest person in the room, you're probably in the wrong room, right? You need to find the circle of friends that are achievers like you want to be, or has similar goals, or similar industry, or whatever it might be, right? And it's really tricky. It's very hard once you have these established friendships that you're just like, it's just a time hawk, and I get nothing out of it, and it's always, and I'm sure we have friends like that, right? Maybe we move on from that. I know it's hard, but it's just, it drags you down. And we're talking about, what's the gold nuggets in getting more out of life? Well, that's one of them, as cruel as it may sound on face value. Anyone? Either got a friend like that or think I'm stupid, or it's fine, you can.
Not really a question. I just want to say thank you. I'm feeling validated right now.
Cool. Okay. In whatever way, you're welcome. That's awesome. And again, as long as you get one or two things out of this talk today, I'm really happy. Like, you do not have to agree with everything, but it's just my journey. Okay. So we have 10 minutes left. So let's talk about how we actually do this, because I did promise that. Like, how do we make this into reality? Because we talked about a lot of concepts and a lot about what you should do, etc., right? So it's actually not difficult, it's just really hard, if that makes sense. It's not a lot of steps, yeah. So the first thing is plan. And there's a very specific reason I put this as someone writing on a piece of paper, because write on a damn piece of paper. We are all nerds, and we all put it in Excel, or we put it in Google Notes, or whatever it is we do, and then we never look at it again, right? If you write it down on a piece of paper, and you say, hang it on your fridge, you look at it every damn day. And it's such an important reinforcement. For me writing something by hand, as bad as my handwriting is, it actually makes me remember things better. It makes me think about it more. For some reason, there's some connection between my hand and my brain. So do that, plan it, figure out what it is you want to do, plan it. It doesn't have to be a perfect plan. No, we can't make it perfect. We just do a best effort with what we know right now. And when things change, we reevaluate, we reassess. Plan, really plan. The next part of it is review. As I said, things change all the time, and that will never be different. No, you're not going to have a perfect run at anything. It's just not how life works. So you review. Say, okay, where I'm at. Some people do it a weekly thing, very, very structured, very formal. You go, so Sunday night I'm reviewing my goals, or once a month or whatever. That works for some people. Some people is like, oh, yeah, I doesn't feel like I'm on track. I should better review. So it's more of a reactive thing. Whatever works for you, but review it, because that means you are paying attention to where you're at the moment and how you might make it different, right? Because if you just write something down and leave it for 6 months, you're not going to do it. It's not going to happen, right? You have to review it and look at it all the time. And then, of course, hard work. None of this is easy. Because, and I'm going to bang on it again, I'm sorry, Netflix is easy, right? That's why I don't like it. It is an escape. We don't need it. We don't have to use it. There's many other things we can do to stimulate our brain or relax. But hard work is such an incredibly important part of it. I'm not saying that you have to slave away 14 hours a day. That's not the point. What I mean by hard work is that you need to have some sort of progress all the time that you're happy with. Right? Because otherwise, momentum is everything. If you lose the momentum, and let's say in the book writing thing, if you write 3 chapters and then don't look at it for 4 months, suddenly you're like, mentally you don't even know where to start. You lose the track of the thing. So the hard work is like, just keep doing it, right? And of course, if something really doesn't work out, get rid of it. If it's a goal that you go, I thought I wanted it, but I really don't, okay, remove the goal. It wasn't really that important. That's fine. But the hard work is very important. And then, of course, go all in, right? That's sort of my point. Just go for it. Like, absolutely go all in on whatever it is that you think you want to achieve, whether that's buying a block of land, or it's a book, or it's goals that you want to set, whatever it is that your thing is, don't let anyone stop you. So, because what's the number one easiest things you can do? The absolute easiest thing. I talked to Andrew about this morning. You can't say anything. What's the easiest thing? Quit. Yeah, it's super easy. People do it all the time. In fact, most people do it all the time. It's very easy. Right? Don't. If it's something you really want, just go all in. Just. Don't say just. And then do a thing. Right? Whatever it is, because I'm hoping some of you are thinking right now, yeah, I really wanted to do that blog post, or I really wanted to record that thing, or I really wanted to build the thing, or I really wanted to, whatever it is. Right? Just do one of them. Just do it. Do a thing. It's really rewarding, especially if you celebrate it once you've done it. If it's a reasonable sized thing, don't mow the lawn doesn't count. Just do the thing. Okay, so that's my challenge. Change one thing, whatever it might be. Change one thing today. Anyone don't want to do that? Good. That's 140 people say they're going to change. Good. Cool. So I'm going to leave you with that. Any questions? And by the way, this is AI's version of question time. Alama asking, what's on your mind, NDC Porto? Anyone? Final remarks? And while you are listening to that, if you want, that gives you apparently 40% off the book. Because plug, I don't know.
What do you do if you find out that reaching a goal was the worst thing ever, the worst idea you ever had? Because you thought it would be great, but once you achieved it, you all of a sudden realize that, oh no, this is not what I thought it would be.
So what if you achieve the goal you set out and it's the worst idea you ever had?
Like your YouTube channel. Let's say your goal is to get 1 million subscribers, but to get 1 million subscribers.
You couldn't possibly have known then that it was a bad idea before you completed it, is what you're saying.
Because,
okay.
Yeah.
Okay, move on. Like you can't, that you did the thing and you realized, that was a bit shit. Then, okay, have that experience, that lesson, and move on.
Now you have 1 million people who expect you to provide them content that depend on you, and you feel obliged to give them.
Why? Why is it their decision?
Because you got them to subscribe to you.
Yeah, but there's many other channels they can subscribe to. Okay. You know, if you want to be kind, you can go, sorry, it's not for me, go over here. I don't think that's a problem. I think not achieving the goal is worse than achieving it and not liking it, if that makes sense. I think it's a much better sense of achievement to have the goal done and go, I freaking did it. And then go, but actually not for me. And it happens all the time in education, by the way. I thought I was going to be an accountant. Yeah, right? It happens all the time. I almost went and studied accounting as well. So yeah, it happens all the time. So unless there's other questions, anything, we've got like 2 minutes left. That's it. I'm gonna hear what Andrew has to say.
It's less of a question and more an alternative answer for the last question. Is that all right?
Is it an alternative fact?
No.
Good, because then you can leave.
Sometimes when we achieve goals and we're disappointed when we've achieved the goals, it's because we misunderstood what we were actually wanting to achieve.
That's good.
So, for example, I also do a lot of coaching and mentoring, and often people come to me and they'll say, I ask them, why do you want to be coached and mentored? And sometimes people will say things like, because I want to get rich. And then, of course, I will try and double-click into that and go, well, why do you want to get rich? And a perfect example of this was a lady came to me, said she wanted to be rich, and I dug into it. She'd grown up in Poland, and for her, stability, money meant stability. She grew up not being able to feed her family. And so for her, money meant she could always put food in their mouths. If I'd have taken that at surface value and said, okay, you want to be rich, become a contractor, that would have been the worst possible advice for her. And so sometimes when we're in these places where we meet a goal and we're disappointed when we meet it, it's because that isn't actually what we wanted. We wanted it to fulfill a deeper level need, and the goal that we met, we thought would give us that deeper level need, but we've missed the mark. And
why are you not doing this talk? That's way better.
So yeah, if you do end up in that scenario, it's worthwhile trying to dig deeper and go, why did I want that? What was I trying to fulfill by meeting that goal?
And actually bring it back to that's why you need mentors sometimes. Because you're not sure exactly what it is. You know which direction, but you're not sure exactly how. Mentoring can certainly help with that. So I did promise books. You're going to get a book because you're writing a book. The Gentleman with the Property and The Good Friends. And there was 2 more. Who else? Jeez, you're supposed to put your hand up. There you go. And up there. Or you can as well. 6 is good. Just come and see me after, and I'll tell you what to do, if that's all right. But that's it. That's all I have. I hope you got something out of it, and I hope you had a fantastic NDC Porto. Thanks for coming, and enjoy the break.